Good evening and good morning and good evening from Washington, D.C. My name is Allison Torres. I am the event administrator for the International Development Team at the American National Standards Institute. I will be your MC for today. Can everyone hear me okay?
Yes.
Yes, I can hear you. Good morning.
I can hear you guys as well. Thank you for that confirmation. And thank you for joining the ASEAN and U.S. Electrical Vehicle Workshop on Technical Standards. This workshop is sponsored through USTDA's Indo-Pacific Standards and Technology Cooperation Program and co-organized with the Association of Southeast Asian Nations under the U.S. and ASEAN Electrical Vehicle Initiative as part of the ASEAN-U.S. Transport Cooperation Work Plan, along with the U.S. Department of Transportation. Ladies and gentlemen, it is so great to have everyone here, and we really hope that you will enjoy and value today's event. Before we begin, we just want to go over a few housekeeping items. First, we ask that all participants are muted without video upon entry. Second, we ask that you please use our Q&A function of Zoom to submit any questions for the speakers throughout this event. We will have a Q&A time built into each session, and we'll do our best to cover as many of the submitted questions. Additionally, we'll keep a record of the submitted questions and seek follow-up answers to those we were unable to respond following the event, and we'll make these available as part of the workshop materials. Third, this event will be recorded as indicated when joining the Zoom lobby. This recording will be available as part of the workshop materials after the event closes. Fourth, we ask that you adjust your screen name to display your name or the organization you represent. This will help us keep accurate records and ensure that we can provide additional workshop materials and follow up after the event. If you are experiencing any technical issues, please feel free to directly message myself or any of my other ANSI colleagues, Lai-Ying Yuan and Joseph Conrad. Finally, at the end of both today's and tomorrow's session, we will provide a link for you to fill out and post event survey. We will make the workshop materials available to anyone who will complete the survey. Additionally, if you plan to attend both days, you can use the same link that you used for today's meeting. With all of that said, I'd like to officially begin our workshop by moving to our welcome and opening remarks speakers. Our first speaker for today is Mr. Harry Prabowo, Head of Safety Management Directorate of Road Transport Means, Ministry of Transportation of Indonesia. Welcome, Mr. Prabowo. The floor is yours.
Okay, thank you very much. Here, I would like to represent our director. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Good evening in United States, of course. And salam sehat. The Excellencies, ASEAN Secretariat, ASEAN Member States, United States Trade and Development Agency, distinguished participants, ladies and gentlemen. First of all, let us praise our gratitude to our mighty God for the grace and all blessings that we are gathered here today to attend the virtual workshop between ASEAN and United States on the second ASEAN-United States Electric Vehicle Workshop on Technical Standards, with the theme of U.S. Indo-Pacific Standards and Technology Cooperation Program. Allow me to address my gratitude and appreciation to the U.S. on facilitating this event for public and private experts on discussing the international standards along with the electric vehicle supply chain and ecosystem in ASEAN. Ladies and gentlemen, we are aware that environmental sustainability has become a global issue. We are facing a great deal on the issue on greenhouse gas emission. About a quarter of the total of the global greenhouse gas emission comes from transportation sector. Enhancing the awareness on how the transportation has a great deal to the environment, I truly believe that using of electric vehicles is one of the solutions we can rely on reducing the greenhouse gas. Sustainable transportation is one of the aspects of global sustainability, and transition from conventional to electric vehicles will be the significant shift in automotive industry. For electric vehicles, it is quite important to acknowledge and adopt the international standards. In 2019, there were around 7.2 million electric cars, as well as around 350 million units of electric 2 or 3 wheelers globally. I believe that certain strategies and policies on establishing the electric vehicles ecosystem is a great deal in order to achieve the net zero emission. Distinguished ladies and gentlemen, the number of EV utilization have been increased within the ASEAN countries. It is required an integrated planning on how to elaborate the EV ecosystem. In this workshop, we all hope it will help us to improve our EV ecosystem. That includes the inspection and safety method along with building the charging infrastructure. Indonesia, as a member state of ASEAN, has committed to decrease in total of 29% emission by the year of 2030 and will achieve the net zero emission by 2060. We are also setting the target on the total amount of EV by 2025 at least reach around 20% of the total vehicle production. In order to do that, we need to build our EV ecosystem rapidly. Finally, I hope this workshop will provide us with fruitful knowledge on developing the technologies, on engaging all the actors to the development of electric vehicle ecosystem in ASEAN member states. Also, may this event strengthen our collaboration between United States and ASEAN. Thank you. Have a nice workshop. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Mr. Prabawa. I appreciate all those words. And now we will begin the next following opening remarks with Mr. Kevin Tuhurst, Country Manager Indo-Pacific at the United States Trade and Development Agency. Kevin, the floor is yours.
Thank you, Allison, and thank you again to Mr. Hari Prabowo of the Ministry of Transportation of Indonesia for your opening remarks. Good morning to our partners joining us from across the ASEAN region, and good evening to our colleagues here in the United States. On behalf of the U.S. Trade and Development Agency, it is my pleasure to welcome you to this ASEAN-U.S. Electric Vehicle Workshop on Technical Standards. Thank you for joining us here today, and a special thank you to the ASEAN Secretariat and the U.S. Department of Transportation for your partnership on this event. I'd also like to thank our supporting organizer, the American National Standards Institute, and all of our speakers for their contributions. The electrification of transportation is critical to our global climate ambitions, and both the United States and ASEAN are focused intently on scaling the role of EVs in meeting our decarbonization goals. That is why US TDA is proud to be supporting the US government's engagement with ASEAN under the US-ASEAN Transportation Dialogue Partnership, and in particular, the US-ASEAN Electric Vehicle Initiative, launched by President Biden at the US-ASEAN Summit in Cambodia in November. Under this initiative, the United States and ASEAN are working together to develop an integrated EV ecosystem in Southeast Asia by driving new resources to planning for EV infrastructure, technical assistance and capacity building, and partnerships with the US private sector to help accelerate the adoption of EVs across the region. Today's workshop is the second in a series of EV-related workshops held by the US and ASEAN, and it is also the sixth and final workshop under US TDA's own US Indo-Pacific Standards and Technology Cooperation Program. The first ASEAN-US EV workshop was held in October and focused on the EV ecosystem in ASEAN and shared experiences from both ASEAN and the United States on policy planning and private sector engagement for EV adoption. Our workshop beginning today will focus on the technical standards and regulations that will underpin the growth of the EV industry here in ASEAN and globally. Over the course of these 2 days, you will hear from leading private sector experts and government officials on technical standards and international and US best practices for vehicle safety, smart charging infrastructure, EV battery design and recycling, and other key topics. Today, we will focus on the EV charging infrastructure that is essential to EV system development. We will also hear from leading experts from the US and ASEAN on why standards coordination is critical to EV adoption, and how the US, for example, collaborates between government and private sector on standards development. During tomorrow's session, we will turn to two other key topics that are of great interest to stakeholders both in ASEAN and the United States: safety standards for electric vehicles and standards for EV batteries, including battery production, transportation, recycling, and waste management. I look forward to hearing how the private sector is driving innovations in this space and where industry and government can collaborate on sector solutions. This partnership between government and the private sector is at the heart of US TDA's mission. US TDA is the US government's overseas infrastructure project preparation agency. In addition to industry workshops like this EV workshop today, US TDA supports project preparation assistance to help our partners in overseas markets plan for their infrastructure development goals. Our toolkit includes grant-based feasibility studies, technical assistance, and pilot projects that help move capital-intensive infrastructure projects from the earliest concept stage to financing and implementation. As just one example, US TDA is supporting a grant to Thai company SEG International for a feasibility study to support the transition of SEG's fleet to electric vehicles and to define the technical requirements for EV charging infrastructure across SEG's facilities in Thailand. I encourage you to reach out to me, my colleagues, or our other organizers if you have ideas for how US TDA can support the development of EV-related infrastructure in ASEAN through US TDA's grant-based project preparation tools. Our is to identify the best projects and opportunities to support high-quality EV infrastructure development, and ultimately to increase our portfolio of projects that will drive improved mobility and reduce vehicle emissions across the region. With that, I would like to thank you again for your participation and engagement over the next 2 days. I look forward to our conversation, and I will turn it back to the ANSI team to introduce today's first session. Thank you.
Thank you so much, Kevin. I believe everyone here is extremely excited for this event after those very encouraging words from both of you. And before we move forward, if we can have both of you on the screen for a quick group photo. Great. And we will take the screenshot on 3, 2, oh, 1 second. All right. And we will take the screenshot on 3, 2, 1. Thank you. And now we will move into our very first session of the day, the standards for common and smart charging infrastructure. Before we begin, I'd like to remind everyone to please reserve any questions to our Q&A function in Zoom. Now, allow me to welcome our moderator for this first session, Mr. William Gauss, Global Ground Vehicle Standards, SAE International. Mr. Gauss, the floor is yours. You're on mute, sir.
Thank you, Allison.
Yes, now we can
Good
hear you.
morning, everyone, and good evening.
Good morning.
To say good afternoon, I don't think we have anybody in Hawaii enjoying a nice lunch at the beach right now. Want to thank you for the ANSI team for all the work put through this, and of course for the work that USTDA does relentlessly to support the missions of cleaner and safer transportation. We have in the first session, we have 3 speakers in this topic of standards for common charging and smart charging infrastructure. Probably nearly 100 years or so of technical and project management experience between the 3 speakers. They all started working there about 10 years old, I think. Very impressive resumes are included in the bios. I please encourage you to look at those in the PDF. We have United Laboratories, Mobility UL representation. We have from Argonne National Lab, Department of Energy National Laboratory expert. I want to give special recognition that also is a chair of an SAE committee. And we have National Electrical Manufacturers Association representatives. The 3 speakers are Joe Bablow, and they're going to be in order. It's on your agenda. And then Steve Griffith of NEMA and Ted Bond. And good to see you here again, Ted. We were together in a meeting a little while ago. I just put in a shameless plug also that simultaneous to this week, U.S. government industry meeting is happening here in Washington, D.C. And I see some of the participants signed in are also attending our meeting. So thank you for your dedication for the long days. And with that, I would like to introduce Joe first to come on board and go through his deck. He's going to discuss energy storage and e-mobility. So Joe, if we can get you to the screen. Oh,
Okay.
Yeah.
Let me see if I can get it to go. All right. It says I'm sharing, so I assume you can see.
We can.
Screen?
Joe. Excellent.
Can.
Audio is perfect too. Thank you.
Okay, so everybody sees the slide, right? Is that correct, or do you see me?
No, we're seeing the slide.
Okay, perfect. Thank you. Okay, sorry for the little clip there at the beginning, but thanks everybody for the opportunity to speak today. We've had a lot of eloquent description of what we're trying to do here, and really the focus of my little 10 to 12 minutes here is really going to be around, as we try to drive a larger increase in electric vehicles, what does that do with the standards that we have? I won't go through the bio, but I've been doing this for 27 years, mostly in the area of standards development. So from the electrical safety standard aspect, that's where I'm coming from here today. So it's not the prettiest slide in the world, but here's some colorful for you, some colorful information for you. The different bubbles here, the bubbles in blue are established standards that exist today for electrical safety. And on the left side, you'll see North American standards. On the right side, you'll see IEC standards or an EU type European standard. These, the rows correlate. So you'll see there's AC output devices, DC output devices, charge couplers, and then we have the green bubbles at the bottom for bidirectional chargers. And those are green because things are still in development in that area. So I won't read this slide to you, but essentially I just want to point some things out. For North American standards, you'll see we have 3 different designations with UL for the US, CSA for Canada, and NMX for Mexico, as all of these standards are trinationally harmonized for North America. So when I speak about them today, I'm just going to reference the UL number for the sake of convenience, but it's UL 2594 for AC devices, which would correlate to the IEC 61851 or IEC 62752 standard for IEC. I say correlate because they're not exactly harmonized, but they do use the same safety concepts, even though formatting or approach may be different. So you can see this. I'll let you review this on your own as it goes through, but you can see that there's actual correlation between North American standards and IEC standards that exist today, already published, already there, handling what's already out there in the field. But for bidirectional chargers, we have what's referred to as UL 9741, which is essentially taking the EV as a distributed energy resource and using a grid interactive inverter requirements from UL 1741 to tie it to the grid. And that is currently being harmonized with Canada, which will be CSA 348. That's the portion that's in development. So 9741 is published. The harmonized version will be published soon by the end of the first quarter here, I believe. And in IEC, that's all under development. So the bidirectional area is still more of an innovative type thing as far as standards are concerned. Even though you see it on commercials, you see it being used, it's still being standardized. So these standards exist today to cover what is already out there. But obviously, as we increase the use of electrification, we start moving into delivery vans, trucks, potentially ferries that are moving cars across rivers, things of this nature. We have a need to charge faster and to charge larger batteries in a shorter amount of time. And so there's different aspects of what's happening, different innovations around technology, advances in what's happening in this area that are really being standardized. Now, standards are always reactive. Therefore, standards will come after the products. So we may see these products in the market. They may already be used, but they're not standardized from an electrical safety point of view. So I'm just going to talk about 3 of these here today. And essentially, this is going to cover megawatt charging, which I'm assuming we're all familiar with to some extent. But megawatt charging is going to deal with new systems, new charging systems that will be different than what's already out on the market today, what's already being standardized today. They'll have new ratings. The highest rating for megawatts is 1500 volts DC, 3000 amps. We may be talking about this. Other people may be talking about this in more detail. New couplers will be involved. We won't be using the same existing couplers that are out there today. And of course, it's going to require some tweaks to communication protocol and use case. And so we're going to be looking at new products that are coming out, but essentially it's intended to be a higher power transfer in order to charge larger batteries in a shorter amount of time and make use of larger vehicles. In addition to that, moving away from that, the second bullet is what we are considering or calling today non-grid tied charging systems. These could be a package deal with battery storage and some PV that can be brought in a flatbed truck and dropped in a parking lot or in a field where there's a fair or a carnival for temporary electric vehicle charging. They could also be larger systems that are permanently installed, but in remote areas where we're relying on the energy storage and PV and wind and things of this nature to actually charge vehicles in these remote areas, but there may not be an exact grid tied system. And it doesn't seem like that would be much different, but if we have energy storage that comes from one manufacturer, PV inverters that come from another, the EV chargers a third, and they're all just showing up and being put together in the field, the idea of the system has to be standardized in some manner. And the safe operation of that system, once it's installed in the field, has to be covered by some sort of standardization. And then, of course, the third bullet point has to deal with automatic connection devices, which are also in the development stages for standards. And we have pantograph type systems, could raise or lower from the top of a bus, or you can have connector-based systems with robotic type attachments to just essentially eliminate the human aspect of plugging in and utilizing an automatic connection device to plug in the vehicle when charging. So all of these are being developed right now. I am actively involved in standards development, both on the IEC side and in the North American side, in all of these areas from an electrical safety perspective. The one thing that I will say is the North American electrical safety standards are design agnostic. So how these look, how they're put together, what they're doing, all of that is up to the manufacturer. The standards will never tell you how to create something. There are other standards that do that. There may be SAE standards, there may be ISO standards in Europe that deal with design aspects, but we won't cover them within UL standards. But also, as electric vehicles, the use of electric vehicles increases, it's raising questions that are expanding outside. I'm losing my thing here. That are expanding outside of what we can do with an electrical safety standard. So I have some potential implications here that I'd like to bring up simply because they're discussion points. So we always have the idea of more cars on the road requires more infrastructure, and any kind of limitation of that available infrastructure would impact the ability to be able to charge cars, and sometimes can create workarounds. Look at a workaround as in the idea of someone dropping an extension cord from a second-story apartment building because they want to charge the car and there's no infrastructure there, right? So we don't want workarounds. We want to have safe and reliable charging to be in place. Also, there's also the idea of being EV ready. California is a good example where they are using building codes to actually state that all new construction must be EV ready. So you have to plan for an EV, even if you don't know if an EV will be there. There are also concerns around fire in established buildings. And this is a hard question for me. I deal with EV on a daily basis, EV charging on a daily basis. People come to me and ask me this question. I am not a building expert. I am not a construction person. So the idea of older buildings where we have EV charging either beneath, underneath, underground parking, or next to buildings, they're worried about fire or thermal incidents with the batteries in these vehicles. Will this be safe for the building? Do we need fire suppression in these areas? Is it safe to have EVs parked under a building? These kinds of questions have nothing to really do with the charging aspect and really are outside of my area, but this is a question that people are asking. And then also we have the lessons learned, which I'm going to give an example of a warehouse fire in the Chicago area. It was an abandoned warehouse. It was empty, and a company decided to store some batteries in there. There was a thermal incident and there was a fire. The batteries went up in flame. And when the first responders showed up, they tried to put out what they thought was a fire in an empty warehouse. No idea that there were batteries in there. And the first thing the fire chief said in the news conference was, "I wish we would have known what was in this warehouse." And so the idea of storing batteries, utilizing batteries for energy storage, having them stored in warehouses, first responder awareness of what's happening, where these batteries are, and what they're actually working with is also important. So all of this has to be standardized in some way. We have to look at these aspects in some way, but they fall outside of electrical safety standards. But the general public safety perception is always the key, right? The more incidents occur, the more the public perception is damaged. And obviously, sensational news sells. So if there's bad news, such as a fire on an EV, that's going to make the news, but you're never going to hear the stories of every EV that charged without a problem, right? That's not going to make the news. So the one-offs where there's an incident will be caught into people's perceptions, and we want to make sure that we try to limit those as much as possible. Okay, so with that said, I will stop there, and we can move to the next speaker.
Great. Thank you so much, Joe. I'd like to call on now with the Steve Griffin, who's with NEMA. He's Director of Transportation Systems and Cybersecurity. Oh, great, Steve. I see you on video.
Great. Everyone hear me all right? I'm doing a sound check.
Quite clear to me.
Okay. I think you were going to run my slides, Joe. I think, okay, perfect. He's got it. Okay. Everyone see my slides all right? Yes.
Yes.
Okay. Thank you for the opportunity to give some NEMA perspectives on what we're going to call codes and standards that are kind of essential for this infrastructure. So we can jump to the next slide, please. So I'm going to talk a little bit about the bipartisan infrastructure law and its impacts and what we're seeing in NEMA, what we view it, how we view EV infrastructure, a specific NEMA EVSE standard, a little bit more detail on EV ready, EV capable. Talk a little about the NEC Article 625 and then a related standard, NEMA TS10. So you can go to the next slide, please. So this obviously is a little bit dated, but I think really the message here is that you're at the point now where electric vehicles are costing about the same as internal combustion engines when you consider the total cost of ownership. I mean, there's advancements in battery technology, increasing the distance that an EV can travel on a single charge. There's more options from automobile manufacturers. I was at CES a few weeks ago in Las Vegas, and nearly every vehicle that was shown was electric. And then there's a lot of investment from the US federal government in the deployment of EV charge infrastructure, trying to address that range anxiety. Next slide. So the bipartisan infrastructure law created a new joint office that collaborates between the US Department of Energy and the US DOT. That's a critical component that provides support, expertise to a multitude of programs that are deploying a network of electric vehicle chargers, zero emission fueling infrastructure. They're doling out about $5 billion over the next 5 years to all the states to create a network of EV charging stations designated along alternative fuel corridors. The funds are available under what we're calling the National Electric Vehicle Infrastructure NEVI program. NEMA has been very involved in providing comments on those. In addition, the joint office working with the Association of State Energy Officials, NASIO, the American Association of State Highway and Transportation Officials, which is AASHTO. So there's a lot of collaboration going around in this space to develop and deploy a national electric vehicle charging network. Next slide. You heard me talk about the joint office. I think both Joe, Ted, and I are involved in the ANSI roadmap of standards and codes for electric vehicles at scale. You're going to hear more about that in the next panel, so I won't go into that, but there's a link to where that is. But you can move to the next slide. I want to kind of focus on our perspectives of the infrastructure. So I think it's important that electric vehicle infrastructure is not just hardware equipment. It's a combination of hardware, software, cables, cable management, analytics that are integrated into a network, delivers energy safely, reliably, and efficiently to a vehicle. This could include additional elements like lighting, controls, and other communication devices, enabling the use of the charging equipment and enhancing the safety of the overall environment. We're very much in favor of the efforts to develop and sustain nationwide electric vehicle charging infrastructure. Obviously, it's going to strive towards standardization and interoperability, and allow for communication and coordination between the vehicle, the charging station, and the grid to maximize the benefit and convenience for vehicle owners, not putting undue stress on the grid. These chargers don't exist in isolation. They're interconnected with the grid, with supporting electrical equipment and infrastructure. Every charger and charging system has customer side power distribution equipment that supplies power to and between the chargers. In some cases, chargers are deployed in conjunction with on-site battery storage with EV chargers. Those systems may be distinct from the electrical system of the building. Being deployed in that manner will allow those on-site batteries to charge and discharge from the grid through like a large inverter. Also, renewable power could be generated and stored when demand is low and then released during periods of peak charging. Next slide, please. Obviously, these have all got to be interoperable with all electric vehicles. For a charging system to energize a vehicle's battery, there's got to be a common physical connection point and a handshake between the vehicle's battery management system and the charger. That BMS then communicates parameters of the battery to the charger, like state of charge, power, capability, environmental conditions, and other data that are critical to both safety and battery longevity. You heard about UL standards. It's important that they're complying with that. I'm going to talk a little bit more detail about the NEC 625 later. Also, cybersecurity is pretty key. There's really two main areas of concern. You're securing physical safety and personal information and protecting operational integrity of the infrastructure. And there's three kind of overarching principles. Boot security, that the manufacturer approved and authenticated hardware devices to authenticate the operating systems and the software when a charge is booted up. Secure over-the-air updates, updating software and deployed chargers. And then how do you protect secure customer information? These chargers may store sensitive data like personally identified information or payment information. So let's go to the next slide. I'll talk about a NEMA standard, which is NEMA EVSE1, which describes a protocol for authenticating EV charging using ISO IEC contactless proximity RFID type credentials. So this authentication provides a little bit of assurance to the charging network that the driver is the correct authorized party incurring a financial or other obligation. Similarly, the driver can have confidence that the transactions have not been authenticated using forged or fraudulent credentials. Next slide. The protocol in this standard enables secure and trustable EV charging to take place for both the provider and the consumer. It applies to intra-network operation as well as operation across inter-networked multi-operator EV charging networks, with the main difference in the latter case being that authentication takes place at the foreign EV charging network responsible for issuing the credential. The authentication method described is a form of external identification that can be used in parallel with the ISO 15118 or other standards. Some electric vehicle charge equipment support only contactless authentication. Others support ISO 15118. You have the option to kind of choose which method to use based on payment methods, credit, debit cards, or other general payment methods. And there's a link to where the standard is located. The next slide, which is, I think, a key component in the development of guidance for EV infrastructure, in which you heard Joe allude to, is EV ready and EV capable, and getting those into both commercial and residential building and energy codes. What you're essentially doing is you're future-proofing buildings so they can accommodate an EV or an EVSE. So next slide. EV ready is basically a parking space that includes a raceway, electrical panel service capacity, overcurrent protection, devices, wire, and termination points like a junction box with a service loop or landed within an EVSE. EV capable is a parking space that has a raceway allocated in a sub panel to accommodate future EVSE installations, but not the EVSE itself. Next slide. There are a lot of municipalities and locations that already have EV ready requirements in their jurisdictions. We've been very much involved with the International Energy Conservation Code, or the IECC, to get EV ready requirements into the 2024 code. Back in June of last year, the residential committee overwhelmingly voted to include EV ready capable parking spaces for all dwelling units in the residential code. So that means basically all new dwelling units constructed under the 2024 IECC will have access to EV charge capabilities at a minimal future cost. So that process in the 2024 IEC will be finalized later this year, and will continue to push that for the standard inclusion throughout the process. Next slide. Equally important item to talk about is the code. And the National Electric Code, which specifies requirements for safe electrical installations, Article 625 covers the installation of electric vehicle and charging systems. That article has been a part of the code since, I believe, 1996, and usually gets updated every 3 years during the code review cycle. It talks about general definitions, construction and installation. The next slide. So here's its scope. It talks about what it covers. A new thing that was added in the code, electric vehicle premises for the purpose of charging, power export, or bidirectional current flow. A new item has been added to address installations used to export power from electric vehicles to premise wiring. It includes definitions for the equipment, the connector, the output cables. Next slide, please. It talks about the types of cables and the overall length of cables. It talks about required personal protection systems, describes the need for each outlet installed for the purpose of charging EVs to be supplied by individual branch circuits with appropriate overcurrent protection. And each circuit has no other outlets. Next slide, please. It talks about disconnecting multiple feeder or branch connection, ground fault protection, receptacle enclosures. So every 3 years, we're very much involved with the NEC, getting new requirements in regarding 625. I believe we're starting a new cycle now for the 2026 NEC. And finally, the last slide is next slide, please, is a somewhat related standard, NEMA TS10, that applies for EVs, but it talks about how a vehicle will communicate basic safety information using cellular technologies for practical applications like emergency vehicle preemption, preempting traffic lights so an ambulance can get to its destination quicker, or entering a school and work zone, or pedestrian crossing ahead. So this is kind of a similar standard, which will also apply to how an EV would talk to a roadside infrastructure. And you see the URL where it's located right there. And with that, I will stop, and looking forward to questions and discussions at the end of our panel. Thank you.
So thank you very much, Steve. Appreciate that. And I want to then move on to our next panelist, Ted Bond, and I introduce him now, and he'll also be in a following panel. And I'll start with Ted is an extremely dedicated, knowledgeable subject matter expert who's been supporting SAE and is a current chair of the Megawatt Charging Committee. And Ted and I have worked together at various events, and I'm so glad he's here in the panel to join us. So with that, Ted, I'll let you take over with your slide deck. Thank you.
Okay, is that to say that I'm sharing slides? Oh, there you go. Okay. So again, my name's Ted Bone. I work at Argonne National Lab. I'm going to go a little bit faster and do what I call meta. I'm going to talk about standards, but without diving into them, because we would spend hours going through that. So this slide just summarizes what we're going to talk about today on interoperability, cost-effective connectivity, and then of course on the megawatt side of things. So in this photo on the upper right, you can just see the 3 couplers that we're holding. This is the first event that these were publicly shown. So these are the J3271 3000 amp couplers that Joe was mentioning, and that we're working on in the standards committees. I don't see the button for changing slides, Joe. Where? Anyway, let's just do it that way. Next slide. And so this slide got a little bit fuzzy on the PDF, but what's mainly important about this one is rows and columns. So in the tan box, everything in the center. So the green box talks about cybersecurity, and basically everything has to be basically cyber secure. Within that, we have the tan box, which is interoperability. Each of these systems has to work seamlessly with other systems, and as Joe was saying, with different manufacturers, different versions, legacy, firmware, software, hardware. There's all these different changes that compromise interoperability. So J2953 series covers that. Looking in a little bit more, the first column, J2836, covers all the use cases of the smart grid, DC systems, distributed energy resources, diagnostics, customer home area network, and then of course wireless power transfer. The next column is messages and signals. And that one, basically 2847 series, has the messages that are used for AC charging, for DC charging, for bidirectional power flow, for wireless, for diagnostics. So how those messages and protocols are put in there. And there's a dual to most of these within the IEC and ISO series. And the next one you can see 2931 is a physical layer. And so 2931 1 through 6 just talk about the way that the messages go. And you can see that /5 is internet, 802.11 for wireless, and then of course 3072 is the bidirectional part. Next slide. So this is a little bit of an eye chart, and again, the main thing is to impress you that SAE, much like my favorite joke, standards, we got hundreds of them. And so in the right in the orange, you can see the EV charging standards, some that we've mentioned before, 1772, 2847, 2894, 2931, 3172. So again, kind of alphabet soup, but we're going to see more examples of that in the next slides. But this is just to kind of summarize that most of the things that we talked about in the opening comments about how we do things together internationally, how we harmonize, how GBT, JARI, ISO, IEC, SAE, IEEE, how all those different organizations can work together globally to break down trade barriers. Next. So again, if standards are harmonized, we have lower trade barriers. This slide kind of gives a survey stating the obvious, that use smaller connectors on smaller vehicles, medium-sized connector on medium vehicles, and bigger connectors on big vehicles. So on the lower left, you can see the J1772 and Tesla proprietary connector run about 19.2 kilowatt on AC power. To the right of that is the J3068, which is very similar to the Type 2 IEC connector, and it can run about 120 kilowatt to 320 kilowatt, running three-phase 480 up to 600 volts AC or DC. So again, a very flexible, compact charger for feeding AC power in for onboard chargers. For offboard chargers, the next one over is the 1772 combination charging system, CCS, and currently people are producing up to 500 amp couplers and up to 1,000 volts, this gives us 500 kilowatt. That would be for the medium and heavy duty trucks today. I have another slide that goes into depth on J3105 on the pantographs, basically a mechanized coupler such that when the bus stops and sets the parking brake, the system recognizes that there's a vehicle below, drops the pantograph onto the bus, interlock is made up and power flows. And then of course, when the bus driver releases the parking brake, the pantograph snaps up out of the way and the bus drives away. And then on the right is a representation of the megawatt charging system, and we'll get more into that in the next one. So again, small AC systems in the 20 kilowatt range, medium systems in the 50 to 100 kilowatt range for AC, and then 50 to 350 to 500 kilowatt for DC, and then over to the right on the 600 to 1.5 to 4.5 megawatt. Next slide. So this one is, again, just a little bit of a eye chart on what the communication standards are. And so you can see on the center left is the traditional GBT Chinese-based connector. Two over to that is the CHAdeMO, and the combination of them two is called New GBT or ChowG. And that one goes to 900 kilowatt, 600 amps. And then moving over is the CCS connector we just saw, the Type 1 for North America, the Type 2 for Europe, the Tesla proprietary connector that we just talked about. And then to the right is the MCS connector, and I'll go into more detail of that in other slides. So next. So So this one is worth mentioning on how things are deployed, and we talk about interoperability, compatibility standards. So it was great that we went through the NEC, NEMA, UL, all those different things that have to do with what's in the building and how it gets installed and what kind of permits. And then again, harmonizing how different countries have the same safety levels and equipment that's built for each country can comply to the country's regional safety standards, and that's important. So on the right, where you see the person standing behind the temporary barricade with the orange vest and the lower right red box are the power converters. So you can see a whole row of power converters, all of those just to feed the overhead charging station. So at 600 kilowatt, you need about 4 cabinets to 6 cabinets, depending on how power dense they are. You can see there's a black or a dark gray riser. That's where the power conductors enter and exit this particular setup, such that they're not cast in concrete. They're added on after the building into the building space. You can see the red raceways go up the wall, across the ceiling, and drop down into the pantograph. So next slide. You can see in the upper left what the pantograph looks like when it's retracted. There are 4 contacts, 2 for DC plus and minus, 1 for protective earth, and 1 for the pilot signal to make sure that we have the interlocks and other commands. And then communication, you can see there's a little white square that looks like a Wi-Fi antenna, and that's because it's a Wi-Fi antenna. So wireless communication and control to the vehicles, and then interlocks, and you can just see how the springs pull the system back up. If there's a fail-safe, if the power's dropped out or anything drops out, the system just retracts by itself and the bus isn't stranded in the garage. And of course, if you had a fire, that would be a big deal if you turned off the chargers and the chargers were stuck on the vehicles. So those are some of the standards that are covered in J3105. Next. So this is an example of an interoperability event in Portland. I have more photos coming up, but you can see the matrix of, on the lower left, you can see the vehicle types. It's a little bit hard to read unless you're zoomed in on your screen or on a big screen. But on the right, you can see the charging station manufacturers. And that's what the EVSE and EV pairings are in the ASEAN, DC, and controller areas, and both in forward power flow and reverse power flow for bidirectional charging. But this is how the matrix is set up, and then basically every 30 minutes they blow a whistle, everybody packs up and moves on to the next station, and the vehicles move round robin. Next slide. So here's a picture of most of the site. There's a few more stations that you can't quite see in this photo, but you can see there's a row of about, I think, 30 stations, and then roughly 30 vehicles, and so they just take turns going around. You can see the BMW, the Mach-E, the trucks and buses and delivery trucks and other things. And anybody who's got a system under development wants to know that it works with every charger, and it would be hard for each vehicle to go to each manufacturer. It's a lot of shipping. But if everybody comes to one event, like this one that was hosted in Portland in October, you spend 3 days setting up and rotating through and testing different aspects of it. So it gives everybody a chance to go one-on-one. So next, so that's how interoperability is tested here in North America. And of course, there are events in Asia and Europe likewise. So my last topic is on dispensing measurement systems and weights and measures certification. I didn't have time to make a big slide on it, but there's something called the OIML, which is a treaty between, it's the International Treaty on Metrology Légale. Anyway, so the idea is that it's a French acronym, but the idea is that each country treats their measurement systems and their sealing and security in the same way. And so R46 is a guide that is a adaptation of what's called Handbook 44 in North America. This fixture that you see on the connectors. So if you look in the center photo towards the person's feet, you see an orange cable that's plugged in between the front of the vehicle and the connector from the charging station. And then so the results from the charging station are compared to the results on this test fixture, which is a very precise set of meters and current sensors that have certified accuracy. And the output is what you see on the screen, a PDF result sheet that's used for the inspector to initialize. So this is basically how testing is done. So on the center photo, there is a 500 amp system, and on the right, in the lower center, the part with the big red donut, that's a 3000 amp sensor at 6 part per million accuracy. So extremely accurate, very good current rating, and demonstrated as done. So that's my part. Let's go on to questions.
Thank you very much, Ted. We do have one question in the chat right now so far. And another one just popped up. The first question in the chat is for NEMA and SAE, and maybe either you or I'll answer that one. Ted will see. Do NEMA and SAE are open to adoption license agreements with other countries to be able to adopt the standards? I'll let you answer first, Steve, on NEMA's perspective.
I think I was muted there, my bad.
Sounds great right now.
So, yeah, I think the point that of harmonization across, different nationalities is something that we're definitely open to as far as licensing and stuff like that. I think we take it on a case by case basis, but definitely it's something that we would bring to the table, and we're happy to look at.
And for SAE, somewhat similar. I'll elaborate and say if any government economy online is interested in looking at any of the standards, they can see me, and I will set up a gratis watermark copy for that economy to use. And also, if the economy decides to adopt it, we can do a variety of options on that. One of which is setting up a online reading room that allows the economy staff and then users to view it, and then they can purchase it anywhere. We don't typically have any nationalized standards similar to what some other SDOs do. Ted, do you want to add anything to that from your?
I was going to say your title says SE International, so you represent all countries, all places. So if it's in the language you can read, you can buy the standard and use it. And then the interoperability part, I think, is the most important part. As Joe was mentioning, you can build it to what you believe is a standard, but you have to have some yardstick that's agreed upon by all parties that this is the way we measure interoperability or just operability. And so that's, it leads to the second question on safety and compliance. You need to have some organization, usually your national lab or independent third party, that can assess, is this done to a way of someone other than the person who built it or the group that built it. So that's the one, caveat when you say we're going to adopt it. It's like, well, how do you check your own work? Usually you have to have a third party check your work.
Perfect, Ted. And yeah, so we work very hard to facilitate the adoption of the standards in any country or economy by providing as much information we can for the decision-making process of that. So we have another question here. For electric bus, what would you advise for charger to use to be installed? I've got a cropped chat here for a second here. To be installed along the street, pantograph or other one type, which is opportunity charging, consider technical cost, adaptability, and safety. So
yeah, so I'll just say from the 3105, they come on masts, they come in infrastructure. There's a lot of different ways, but the pantographs are absolutely the safest way because, again, when they're not used, they're up out of the way. Any cords and operators that operate cords, you have to have a human. You have maintenance issues. You have wear and tear. So that usually, and again, just to be clear, the superstructure or the mast and other things cost more than having just a bollard and a charging station, but you don't have to have an operator to do it. The bus operator just has to stop in a certain spot and everything else happens automatically. So but the downside is you also have to have a place to put it, right? So putting a cord on a hook, usually you have more room for that than putting up a mast or whatever. But again, it's all site dependent. And again, Europe's been doing this for a good 10 plus years. And the Schiphol airport has, I think, 120, chargers in their circulator buses. So it's widely deployed in some areas because the operators don't have any responsibilities other than driving the bus.
thank you. Next question is for you, Steve. On an EVI network and connected to the cloud, what would be your opinion on having a single entity, an agency or a department, govern information from all the charging stations?
So that's a good question. I think that's actually something we've kind of addressed as we're looking at all these RFI comments. I think there's you have to make sure that this entity is able to take the information from these chargers, effectively use it, You'll need to make sure that there's appropriate kind of training or people that are able to look at the data from the chargers. Obviously, I think you want to make sure that you're getting manufacturer input. I think that would be a challenge, in my opinion. It's something that could be explored, but I think that'd be a challenge to staff it, to resource it, so it's governing these chargers and these networks appropriately.
Thank you. So another question, anonymous, and I guess for anyone, we are discussing about battery charging, but do you think battery swap will also be a possible option considering the shorter process compared to charging?
Joe, you want to take that, or?
Yeah, I'll say something about that.
Yeah,
So battery swapping has its niche, right? But it does have there are some problems with that, or I should say challenges with that, simply because the shape of the battery, the real estate, where it's located, how it comes on and off a car, none of that is standardized, right? So to have one facility that can change every vehicle's battery is kind of a pipe dream, right? But when we start looking at fleet applications or things like that, where you can have a fleet of taxi cabs that are all the same way, maybe battery swap makes sense in that case. So it really is kind of dependent on the use case and how it's being put together and how you decide to use that. But general battery swap for passenger vehicles on a day-by-day basis, I don't see that as being something that's as viable as just plugging in.
Yeah, and I'll just add on that it is a proprietary method right now with the consortiums, led by Honda and Yamaha and others, for the two-wheel vehicles, and then again for the light-duty vehicles, and then BYD and others for the heavy-duty vehicles. So there's kind of three main brackets of places that are being used, and again they have swapping stations that are in the thousands, right? So that's not small. But Project Better Place, it imploded because of the economics of siting the location. But you have to store these batteries. So again, for every vehicle, roughly has to be 3 batteries: one that's in use, one that's being charged, and one that's ready to go. And so that's a problem on warehousing and other things. So again, it's good if you get enough space for everything, but that's what sunk Project Better Place, was finding a place to put these things. So, but again, it's in use, and it's a good idea when, as Joe said, when it works, it works. But when it's not a good fit, it's going to be way more expensive than just charging the vehicle you have. And of course, scheduling. We didn't really talk about scheduling software, but there's a lot of things where you can have reservations, where you make sure that the vehicle has a spot, and that spot has energy, and that the vehicle is back in service when it's needed to. So that's the flip side of battery swapping, is basically just having prescriptive charging, that you know when and how and where you're going to charge.
Let me elaborate, Ted and Joe, on the question and ask, because I know self-serving, the SAE Micromobility Committee is looking at form factors for micromobility for the machines. But that's a whole scaled down, smaller device. And like
it's the same question. Where do I charge the battery, whether it be the size of a cordless tool or the size of an SUV? So the ones that go for the truck swapping, I think those are 2,000 pounds each, and so they're pretty big assembly. But they swap out in less than 2 minutes, right? So it's not really a matter of that, but the facilities to do it, right, have to be there. Right. But anyway, next question.
Yeah, next question says, doing it globally or ASEAN to standardize, just to confirm that discussion includes European and China.
So I think that's for our organizers, like what the reach or the trade technical people, like what is the reach of this? So standards are global, right? So IEC is global, SAE is global, and then you have regional standards, like GBT isn't really used anyplace else other than China.
Oh, we got a question. Good, very good. In the North American standard, have full interoperability with IEC standard. For a region who does not yet have regional standard on EV infrastructure, what will be your advice in developing ASEAN regional standard? Build our own regional standard or use available international standards such as IEC?
Yeah, and I can go ahead, Joe.
I can go first. I would say one of the issues that we don't want to do is reinvent the wheel. right? So if the IEC standard is there and it suits the purpose, I suggest you use that, right? We also have UL standards that get adopted in various regions. I wouldn't put that out. I wouldn't say we couldn't do that either. So both of those have a slightly different approach, but as I said earlier, but they're both concentrating on the safety aspects in the same way. So either one of those would be fine. I don't see us saying, let's create a brand new standard. Ted referenced the GBT standard for China, and that's essentially take the IEC standard and then create the GBT standard, right? And that does happen, but it does create different rules. So now we have different rules for each country rather than a standardized way to do this in a region, right? So I would say let's not hopefully create our own. Let's utilize what's already there, but that's not my call to make, right? So that's just my suggestion.
And I was going to add on the export part of it. If you're harmonized to an international standard, right, you can export anywhere. If you're harmonized to a regional standard, you might have homologation, you might have a ban on using it in certain countries because you have a safety issue, because one side interprets wording one way, the other side interprets a different way. So that's where IEC and SAE and IEEE harmonize on that wording to make sure everybody uses the same words in the same way. And if we're measuring things, using the reference gauge, the exact same unit means the same thing, so we don't have any safety issues. And that's where the interoperability testing comes in, is that we test things, and when we find a gap, we try to rewrite the standard such that there isn't a gap.
I would agree. It makes it a lot easier for a manufacturer when they're designing a charger to an international standard. So I agree with both Joe and Ted on that.
And thank you, three. Now may I call on Joe of ANSI, since you are our host for this, and perhaps make a comment. No.
Joe Conrad?
Yeah, Joe, do you want to say anything? Or are you muted or?
No, sorry. It would defer to Leslie on this, but I think we're not experts on this particular issue.
I thought you had raised hand. Okay. Another question: with all the funding dedicated to deploying EV infrastructure, are you seeing any pushback on any particular code efforts?
Yeah, actually, we are seeing one, and this is a specific code that is looking at motor fuel dispensing facilities and repair garages, which is NFPA 30A. There's language in that code that's very overly restrictive for installing EVSEs at that location. NEMA's been following this effort. We have a lot of concerns with the scope of that committee that was probably better covered in the NEC 625. Also, that committee, I don't think has the relevant stakeholders like, EV manufacturers or automobile manufacturers or other electrical code experts. So we've been kind of following that code, and we have concerns with how that is progressing. So that's one we're seeing for sure.
And I'll add in, there's a lot of concern about interpretation, and especially when there's lack of specificity in the NEVI requirements, how is it interpreted? So this week there is something Consumer EV Charging Experience Council being formed. And so they're getting together, comparing answers to say, what does each industry stakeholder think these requirements mean, especially on reliability and uptime? So that that's not really pushed back, but the idea is that if you're going to make it a requirement, you have to be very clear on how pass-fail goes. And same with the domestic versus import, content. It has to be very clearly defined who gets a subsidy and who doesn't.
Thank you, Ted. Thank you, Steve. So next question. Am I correct that you're referring to SAE standards? Sorry, the CC is not clear, Ted. Yeah.
I use the closed caption a lot, and it gets it wrong. It slaughters some words. So yeah. So when we say the standard, we actually mean international standards defining organizations. So all three: IEEE, SAE, IEC. So and again, when we're harmonizing, we want to make sure each group, we have liaisons on each side. And I said on several. So when we use the same words in the same way. So I'll just leave it at that.
Next, what are your experiences, constraints with regard to tariffs and import related issues?
Well,
so
go ahead.
Yeah, go ahead.
No, go ahead, Ted. My bad.
No, I was just going to say the materials thing has been a problem in the past, and now just speaking for the domestic market, there's a lot of concerns about the content of materials that you have to use to um, uh, uh, get deemed made in the USA in the case of USA. So those are some examples of where you get your materials and how much is built domestically. But everyone's struggling to be qualified for the most amount of the market. So each of the states gets to decide how they spend the money, and the vendors are qualified or excluded depending on how they're designated as far as made in the US and things like that.
Yeah, I agree. I mean, what we're hearing a lot is Buy America, Buy American. And when you're looking at EV chargers, and we know, at least right now in the current market, a lot of those components, the circuit boards, the LCD screens, they're not made in the US. So and it's going to take time to build up the domestic manufacturing capability, right? So I mean, there's waivers that are being granted to phase in requirements. Maybe the idea of tax credits. The concept I've heard a lot is as a manufacturer value add. If you buy a component and you bring it into the US and integrate there, that should count towards domestic content. So a lot of these things that we're seeing to kind of meet this requirement to roll this stuff out.
Andy, you just popped up. It's a question or comment you want to make? To be Andy Paris from Commerce. To be clear, these are U.S. government purchases, right? There's another question. What do you see the trend of using between the AC and DC charger for passenger car market?
I'll answer that since I work a lot on infrastructure. It's about who pays. So when you have a commercial entity who's installing it to recover their money, they split their bet. There's never ever one side or the other. They always install both at almost every location. So you're going to see both. And again, the higher power stations are for high usage corridors. The medium power ones are for convenience, where you'll see 50 kilowatt where there's 50 kilowatt available. Because again, the infrastructure, the wiring, the infrastructure upgrades needed for it, that often determines how much charging you put in. And again, what kind of draw, usually if it's co-located with a mall or another enterprise, they want to draw customers towards the place that's hosting that. So almost nobody makes money on charging alone. It's charging and some other service.
So the next question is it regarding environmental concerns? Is it part of standardization on how to dispose of unused batteries?
It is, especially when repurposing and safety issues and even recycling, a whole bunch of work. So J2990 and 2997 on secondary use. And then there's something called the battery passport, where they have a ledger that's created from cradle to grave on that component. And so a whole bunch of that is being standardized now to basically make the residual value of the batteries higher, and A, so you can recover the materials, or B, you can reuse that component directly, but not necessarily in a vehicle. And that's where some of the safety issues come in. When you use a component not as originally intended, there's liability issues. So standards, lots of them.
Yes, lots. And I do believe that that's one of the focuses for tomorrow's session. As I think I have a colleague that deals with repurposing that is coming to speak on that topic.
Yeah, it's a high bar to achieve. I mean, right now we've got, from a consumer product point of view, probably the car and a motorcycle are the most recycled, reused products in the world right now. So it's a real high bar to achieve, and the safety is, of course, critical in all this sense. Another question, self-serving to SAE. Are you offering training programs for technical? I didn't write the question. Are you offering training programs for technical capacity building of personnel, technicians, et cetera, in the adoption and operation of EV and its support infrastructure?
Can I answer that?
Go ahead, Ted, please. Yeah.
As the instructor for the SAE C2001 course, so write that down. C2001 is taught, I think, at least 5 times. They're getting a second instructor now because there's so much demand. So I taught the course 3 times last year, and I think I'm signed up for 4 more this year. So yeah, SAE does high voltage safety training. There's a whole bunch of courses on how to get your technicians and again, service people, engineers, everybody familiar with the requirements, what they need to do their job correctly. On the implementation of standards, not so much, but that's something we had talked about in some of the groups, is to say, is there a workforce development aspect of, and again, Andy Paris is here, trade and technical, on how do we build up each country's skilled workforce to be ready to do this. And again, just use an example of high voltage safety. Everybody should be, who's around a system, should be aware of what to do and what not to do. And that requires training, and SAE's been doing that for a while.
And during this government industry meeting this week, this has been a topic of all the network breakout sessions on this, other topics involved in training beyond what you just said, Ted. In fact, we talked this morning about in the meeting about first and second responder training with the vehicles, which can't be forgotten also. So
J2990 has all the labels for it, and then 30, I don't know, it's 3025, whatever the number is. The way the labels are used, that goes directly into the training of the people, where the first responders are trained to look at these labels, use the guide, and then there's a UPC label that takes the guide right up to their mobile device. So that kind of training, they're already knowing how labels work on vehicles.
So how are UL standards developed and in the process open to stakeholders in ASEAN? Joe, you think you could take that?
Yes, I can take that. So the UL standards are developed through a consensus process, right? So there's what we call a standards technical panel, of which I would be the member from UL, one person, but we have a balanced committee. And so it is open to anyone that wishes to participate. So anyone from ASEAN, doesn't have to be from the United States. So any entity that would like to join based on their interest group, right? So you can be a manufacturer, you can be a supply chain person, you can be a consumer or a user, different interest groups. We have to have a balanced committee. So as long as we maintain balance on that committee, the work is done through that committee through an online tool. So there's no travel involved, you don't have to come, but everything will be done virtually, and you can be involved in the debate and balloting of changes to the standard. So if anyone is interested, just have them reach out to us at UL and we'll get them to the right people.
And I'll elaborate. It wasn't asked about SE, but I'll mention we're an ANSI open standards organization. People come as individual subject matter experts. They are often sponsored by their employer or so, but they may be completely volunteers of their own time and whatnot. And there's no fee to participate. Our balancing typically occurs at the chairman's discretion, so that we don't have 10 people employed by the same manufacturer or something on a committee that's controlling the vote or so. And we have committees that are as small as a few, half dozen people. We have committees that are 100. And the only challenge to that is making sure we can get a quorum. So you want to, as a chair, Ted, you want to comment on any of that, or your members?
No, I think what you said is right.
So. Next question, and help me, Nancy. We've got a few minutes left, and that's about it. I want to get to them quick though. Do you think the electric charging service could be sustainable when considering most charging service providers have difficulties to get a profit in developed countries like US?
Yeah, I think I covered it before. I think as an entity by itself, it will be a real challenge, but bundling with other services, that's the only way I think you're going to make a profit.
Yeah, I agree with that. I think there's actually some hardware companies that are bundling the software services with it now. So I agree with Ted on that.
And energy services. So that's the other thing that we didn't really cover today. I think I covered in mine in the next section is basically, if you can integrate smart charging, you can actually make money by adjusting the charge rate and selling that capacity, the change in capacity. So that would be one way to have another revenue stream, is by energy services, but different than what we're talking about in this section.
Is it costly to ensure the EV infrastructure? Interesting question. I don't think we have anybody who can talk on this.
Yeah, I think that's a general purpose question of, is anything expensive? Yes. And when you talk about the liability of damaging a vehicle, that's usually not part of the, there's usually disclaimers. So just in the insurance world, there's certain things that say buyer beware. If you charge here and you damage your vehicle, the owner's not, the insurance doesn't cover the car that gets damaged usually. And so that kind of limits your insurance risk. But as far as fire and other protection things, that is what usually raises the bar on, can you get a permit? Can you get your fire marshal to sign off on an installation? And again, the city planners on approving that on egress and all things like that. That all of that's not really affects your insurance, but the things that your insurance protects you against, those are the reasons why installations become more expensive.
We didn't talk about the reverse also of, I mean, the gasoline fueling stations are incredibly robust.
Right.
Are the chargers equivalent against passenger car damage or operator misuse or ignorance or whatever?
Generally, but there's wear and tear. So that, you know, there is the maintenance. So that's another question. Is maintenance a thing you're supposed to budget in? And yes, you're supposed to budget for maintenance. And that's one of the problems in the early charging stations. People didn't budget for maintenance. You had very upset customers who didn't want to come back because the station's always broken or damaged.
You definitely need a maintenance plan when you're installing these chargers. You don't want to have a sunk asset, to your point.
Yeah, it's like a highway. You don't build a highway and then let it fall apart. You keep repatching the highway every year.
I'm not going there.
Yeah, Michigan.
All right, we got a few more. Is it, and Ansi, just, you know, type in if we're overrunning too much, but is there any EVCS platform that we can claim carbon credit or REC kind of?
I can go there. That's where that weights and measures parts comes in, and some of the NIST and OIML standards on how you measure things and how you dispense the energy. That all, it highly depends on the country and who's offering the credits. But the measurement methods, those are covered by standards. So I'll just say that's it. But again, so for instance, at Argonne Lab where I work, we get energy credits for all the charging we do on site. We get carbon offset credits for our green score for our facility, because those are miles of commuting travel that displace carbon. We don't get money for it, we just get credit for it. You know, and attaboys you can't spend.
In the previous discussion, that yours, Ted, we had the interoperability testing. Is that a part of calibration testing to have a calibration certificate? Who would be the approved certified to provide the calibration certificate if there is? And if I could add on to that, Ted, what's involved in terms of time and resource to do the calibration? I mean, we all, you know, fuel delivery is cheap, quick.
Not so much calibration as certification. So that OIML R46 guide, that's published internationally. So that's, and the problem is it's for international. Then you have your regional authorities. Those are the ones who actually put the stamp on your equipment and say for legal for trade. So that's who you have to go to. And so Texas, you know, they've raised the bar really high. It's $2,500 per site just to register it. It's $250 device to register the devices. So they're collecting a lot of revenue to register it. They'll put the stamp on it gladly. So when you say, where would you go? You'll go to your people in Texas, break out your checkbook, and you'll get your sticker, and have to pay for that sticker every year. Other places like California, they have type approval. And so getting your type approval, that's the most important term. You get type approval on your device, then you get regional approval to deploy the device.
Much of today's discussion has focused on passenger car and larger vehicles. Are the standards also taking into consideration EV charging infrastructure needs for smaller vehicles such as motorcycles, scooters, and mopeds, mobility? And I think we have a session on that tomorrow, don't we? I think.
Yeah, they are. It just wasn't in my slides on the 10 minutes, you know, but we do have standards. There are at least 3 standards that cover it in SAE now.
And we do that similar in UL as well. But you have to remember, we mentioned Article 625, motorcycles are defined as electric vehicles as far as the code is concerned. So charging electric motorcycles is the same as charging a passenger vehicle as far as National Electrical Code is concerned in the US.
And I'll elaborate on SAE's comment. We have a taxonomy of micromobility small machines to be used for classification. That's available without charge. It's SAE's property, but it's available. It's a foundational document. There's no fee. I just can't remember the number on it.
It's in the 3000s. It's like 3170, something like that.
Yeah. You told bundling services are the key solution to get through the difficulties, but when those services can realize beyond the pilot project. When services can realize beyond.
I think they're basically saying, can it be sustainable beyond the pilot phase? And the answer is yes. That's what EVgo and all the charge providers are, but they have stock investors, and it's all based on growth. So that's the problem. When you have a pilot, you don't need growth. When you have sustained investor return on investment, they want growth. They want more stations. They want more users. And so that's where the snowball comes in. That the more stations we have, the more EVs we have, the more stations we'll have.
Next question is pretty good. What is the indicative economic life of an EV infrastructure?
Yeah, I tell people it's like cars. Some cars will run perfectly for 15 years, just needing oil changes. Other ones, you got to fix them every other week. I see EV stations the same way. There might be some that have annual maintenance in the last 10 years. There's a lot of stations haven't even made it 2 years before they need to be replaced.
They all break, it's just a question of when, right?
Right.
With the rapid growth of EVCS, have you experienced any impact to grid, and what would be mitigation for such problem?
I'm not sure we have a session on that, but load growth and modeling is something people have been doing for a long time. So it's not a concern here, but again, in different countries with different limitations, but again, the planners all have models that go out 10 years. So nobody is surprised, when they install more EVs. They just say, does it fit the model? Is it below the expectations, above the expectation, or are there clusters? And the clusters are the main issue. Is like when you have a density of if you have a whole neighborhood that buys EVs, that's something that usually becomes a problem. It's not the average, it's the local peaks.
I think the situation for current EV chargers are similar with phone charger 20 years ago, Sony charger, DC charger, Nokia charger center. Now we have the USB-C. Is there a lesson learned from the phone charger situations can be implemented with EV chargers nowadays?
I'll just say maybe, but remind people that the first J1772 standard came out 30 years ago. So it's not a matter of this is new, this is just being used now. And of course, standards evolve. So standards don't, you don't start with with the USB. We have type C now, but you have a type A, you have type B, right? They're all USB, but they're different. And then USB power delivery, like if you plug in the USB A, it's not going to work for power delivery, right? So people say, but they're all USB. It's like, yes, they are. And by the way, USB didn't start as a standard. There was an industry agreement. It was a proprietary method, not proprietary, basically is consensus method. And those are the ones that are most powerful. So the MCS that I'm going to talk about in the next session, that's how it started. It didn't start in the standards world. It started with the end user saying, here's what we think we should do. Then they tossed it over the wall to the standards bodies. And I think that's basically what USB did. And that's when you say, can you learn anything? Exactly. When the customer said, here's what we need, you don't have to guess. They're telling you what they need.
The next question, I'm not sure that there's who ensures that the meters are accurate, and which agency has jurisdiction?
I'm going to laugh because I'm going to pull out a whole bunch of meters down below here. Oh, you can't really see it. Let's see. Anyway, but I have piles of them here. And so I'm the one who does the benchmark assessment on the transfer standards. And in fact, I'm working on a new guide for that. So how the equipment is, the test equipment that's taken out to the field called a transfer standard from your national metrology reference to the transfer standard that goes out. There's a guide being developed for that. So the answer is the test agent can either be a government official or a certified service agent, but their equipment has to be certified and bonded as valid. And that's what the transfer standard is.
Another question, what safety system indicator do the EV have in case of the EV having a problem in the highway?
Yeah, that's the diagnostics we talk about. That's the little, triangle. So it's no different than any other vehicle. If it's got a system fault, it's going to tell you what the fault is, or it's just going to, go into limp home or whatever. I don't see EVs and other stuff being any different.
And it'll have yellow or red. It'll
Right.
have categorized.
Right. One is a warning, the other one's a fault.
For EV charging stations, is it required to set the standard warranty in years on the performance of charging stations?
And that's a trade and technical, that's a consumer question, not a safety question.
SAE Battery Standard Committee was presented and discussed earlier for sizing. How about the fixed position or location for batteries inside an e-bus, in particular, maybe to consider the inner aesthetic of the bus to be standardized considered?
So we have design guides, and I again, I'd have to go back like with you guys. You know, there's a number, and I know it's in my folder someplace, but there's a guide for implementation of batteries in buses, but it's only a guide. It's not a standard. They say, here's a way you can do it, and versus standards say, here's a way you must do it. So guides, yes, standard, no.
Well, we're way over. I mean, we got a lot of great questions and great.
I think you have to
dialogue.
cut it off.
Way
Yeah.
off the chart. I'm sorry. So if maybe there's a couple, any you guys want to make a final comment or anything, and then we'll take I think we'll take a group photo and then we can go. Yeah. And we're still getting questions, so I don't know if we can, if another session goes short, we can pick up or something.
Well, my comment is we got 250 people asking a lot of good questions from multiple regions, and I think that's a good thing. So again, this breaking down trade barriers by having mutual understanding of what expectations are and where to go to find answers, that was a good thing today.
Yeah, glad to be participating. Very enjoyed the discussion.
Very much so.
And I'm just going to have one comment, and it's kind of elaborating what you said earlier, is on the USB-C. This stuff is still being invented. It's still going to be improved. It's going to go on and on and on. It's going to keep getting better and better, and that's kind of exciting. So with that, I think we can do our photo, I guess, or thanks, Allison.
Yes, thank you, Mr. Gauss. And yes, it would be a great opportunity for us to have a group photo. Just give me your best smile and I'll count you down on. We'll take a screenshot on 3, 2, 1. Thank you to all of our speakers and to everyone who submitted the questions in our Q&A form. And we will go ahead and move forward. We will be pressing onto our second session of the day. The United States and ASEAN EV standardization and international cooperation. As a reminder, please feel free to submit any questions you may have to the Q&A function, and we will do our very best to provide a response in the Q&A following our next presentation. To introduce us to the US and ASEAN EV standardization priorities and international cooperation, please welcome to the floor, Ms. Estiara Elazar, Research and Development, Ministry of Transportation of Indonesia. Estiara, the floor is yours. Thank you for being here.
Thank you very much, Alison. Can you hear my well?
I can hear your microphone.
I appreciate the introductions. Very good morning, Jakarta, Excellencies, speakers, delegates, ladies and gentlemen. I would like to welcome you to this second session of the ASEAN-US workshop on technical standards with the topic of ASEAN EV standard priorities and international cooperation. My name is Estiara Elazar. I'm a transport planner from Transport Policy Agency, Ministry of Transport, Indonesia. It is a great honor for me to moderate this session with distinguished speakers and delegates. Distinguished delegates, in this session, we will have 3 speakers and we'll be discussing first, introduction of the ANSI standardization roadmap for EV and the ongoing drafting progress for the latest version. Second, critical standards for EVs at scale and priorities under the codes and standards pillar of the US Department of Energy. Third, mass deployment of EVs and associated infrastructure in the US with international cooperation and engagement. And last but not least, national EV standards, development status, strategies, and other related priorities in ASEAN countries. Before we start, I would like to introduce our distinguished speakers from the US and ASEAN who will deliver the presentation. Our first speaker is Mr. James McCabe, Senior Director, Standard Facilitations at American National Standard Institute. And the second speaker is Mr. Theodore Bond, Principal Electrical Engineer at Argonne National Laboratory. And the third speaker is Mr. Bram Hertasning, Deputy Director for Urban Transport Policy at Transport Policy Agency, Ministry of I'll bring up the presentation. We will turn the time over to the speaker. Mas, ini lost her ID. Hello, Aliza.
Hi. Yes, I can hear you now. It's a little bit of echo, but we lost you
Yes.
for your voice for a second.
Okay, so
You're good now.
I use the different audio in here, so you can allow my colleague for that.
Okay, we can move forward. No worries. As long as we're able to hear you.
Well,
Yes.
okay, so now we will turn the time over to the speaker, and I would like to invite Mr. James McCabe, the Senior Director Standards Facilitations at ANSI. Mr. James McCabe, you will have 10 until 15 minutes to deliver your presentations, and now the floor is yours.
Well, thank you very much. Hello, everyone. It's great to be here with you. I'm going to tell you a little bit about the work that ANSI has done in terms of developing a standardization roadmap for electric vehicles. We can go to the next slide. So hopefully most of the folks on the call have some familiarity with ANSI. We have been around for over 100 years. Unlike NEMA or UL that you heard from previously, or even SAE, ANSI is a standards organization, but we are not a standards developing organization. So we kind of are able to wear the hat of being a neutral facilitator in bringing different parts of the US voluntary standardization community together to address issues around emerging technologies like EVs. We're a membership organization, so organizations like some of the SDOs represented here today are members of ANSI, actively participate in the ANSI Federation. ANSI is also the single representative to ISO, the International Organization for Standardization based in Geneva, Switzerland, as well as the International Electrotechnical Commission through our US National Committee. Next slide, please. So among many of the different things that ANSI does is we organize either one-off workshops or standardization collaboratives. Basically, the idea is bringing together public and private sector stakeholders to talk about what standards currently have been developed, what is in process, and what additional standards might be needed to facilitate the growth of these emerging technologies or to address a public policy priority. We also strive to identify organizations that can perform the work. In many cases, they are already working on it. So it's really capturing a snapshot of work that is underway. Next slide. So why do a roadmap of standards for electric vehicles? A lot of it is about maximizing coordination so that different standards developing organizations know what others are doing, so they're not duplicating effort. The idea is also to help inform stakeholders about where they might want to participate in terms of investing resources and participating in standards development. When we have a forum like this, it helps us to speak a little bit more coherently with international audiences. Obviously, it's about helping to foster the dissemination of the technology. You've got, valid consumer concerns regarding things like safety, interoperability, performance, and so on. And of course, all of the public policy drivers, energy independence, security, and so on. Next slide. So the ANSI Electric Vehicles Standards Panel actually goes back over a decade. Back in 2011, there were some interests within our Electric Technical Commission and the government as well that felt that there was a need to, at that time, coordinate work on EV standards. So the mission of the EVSP is really about developing this roadmap of standards and related conformance programs about facilitating the safe mass deployment of EVs and charging infrastructure here in the United States, but also with a view at international coordination, adaptability, and engagement. And In its prior incarnation, we held workshops in Brussels as well as in Beijing to information share with our international partners. We are just a coordinating body. We are not writing standards. So that, just to reemphasize that, it's really about identifying standards needs. Next slide. So this is just a quick snapshot of the work we did previously, basically in the 2012 to 2014 timeframe. We released 2 versions of a roadmap of standards. We're presently trying to kind of bring them up to date rather, which with the passage of time, obviously a lot has changed in the intervening years. But these are available as a resource on our website if you want to look at the earlier work. Next slide. So more recently, the U.S. Department of Energy's Vehicle Technology Office issued what they call a lab call, a funding opportunity announcement, part of which said, we want to look at the challenges and barriers to the adoption or integration of EVs at scale charging with the grid that might be created by uncoordinated development of codes and standards and the rapid advances in vehicle and charging technologies. So a lab consortium of many of the government labs in the United States was formed to respond to that and got the award. Ted Bone of Argonne National Laboratory was awarded to lead the standards and codes pillar, which identified updating the ANSI standardization roadmap as a key deliverable. And I think it was Steve Griffith who had mentioned that this is tied to the National EV Infrastructure Funding Program that's out to help get the states get money to install charging stations. Next slide. So what is the roadmap? So it's all about identifying codes, standards, and regulations that exist or are in development to address those issues. We identify what we call gaps. That's where there is no published standard or code or regulation that would address a specific issue that is identified, whether that issue is a safety, performance, interoperability, environmental, so on. We also try to suggest prioritize timeframes for standards development and organizations who could do the work. Again, a lot of this is just capturing work that's already in progress and acknowledging it to inform stakeholders. Our focus is on the US market, again, with international harmonization noted in some key areas. And the focus is also for this iteration largely about on-road vehicles and associated charging infrastructure. Next slide. So this slide just kind of shows the way the information is presented in the roadmap. We have a description of the issue. We list any published or in development standards, and depending upon how that question gets answered, then we decide whether or not there is this adequate coverage with existing standards or if there is a gap. We also look at whether there might be any pre-standardization research and development component that is needed before you can write a standard. We have a matrix I won't go into that kind of objectively looks at how we identify whether this is a near, medium, or longer term priority. And then we develop a recommendation for who can address the gap and an organization who might be able to address the gap as well. Next slide. So we have 3 working groups. The first one deals with vehicle systems. It's largely about batteries and energy storage systems. You'll probably hear more about this tomorrow from the UL speaker. These are just the list of topics that are covered. So everything from safety to performance and durability. You've heard a little bit earlier about storage, transportation, handling. We get into the recycling and secondary uses of batteries, and then just overall crash tests and safety. Next slide. I should point out, and I'll talk about our timeline on the last slide, but all of what I'm reporting out now are drafts. So these have yet to be finalized, but based on the discussions to date, I think it's fairly safe to say that we've identified these as gaps. So in the area of battery safety, I guess there's an issue that is being worked on in the World Forum for the Harmonization of Vehicle Standards, dealing with thermal runaway, water immersion, and vibration resistance. There's also the issue of delayed battery overheating events, which is something that the SAE Committee J2929 is looking at. We have issues around safe storage of damaged, in particular, or i.e. meaning unknown condition lithium-ion batteries. Looking at batteries for materials reclamation or recyclability is another area. And then the battery secondary uses. Ted mentioned the passport idea that is being talked about in Europe, and SAE is talking about whether something like that could be used here in the United States. Next slide. Working Group 2 deals with charging infrastructure. Joe Bablow, one of the earlier speakers, is one of the co-chairs of that. So we sort of have two pillars. The first deals with the charging system side, and the other deals with the charging station or site architecture issues. So under the charging system side, we're going to be having sections devoted to DC fast charging, as well as AC level 2 for light duty EVs. We will cover the megawatt charging systems that Ted talked about for the medium and heavy duty vehicles, and then wireless power transfer, whether that's static or dynamic. On the site architecture, these are really the general kind of installation issues, permitting, environmental conditions, the need for ventilation, cable management, things like physical security and accessibility to charging infrastructure. And then we are also looking at any specific installation concerns for different charging scenarios, whether those are residential, workplace, public, highways, and trucks. Next slide. So the preliminary list of gaps identified in this working group, the need for standards to cover both static wireless charging, specifically for the heavy duty high power vehicles, and dynamic across the board. Communication standards for both of those, permitting for export of power from the EVSE to the vehicle, having that addressed in codes, issues around functional management of cables, especially in public parking spaces, labeling of the EVSE load management disconnect to enable first responders to know what power to shut off in an emergency. And then the issue that Joe Bablow remarked on about fire protection for EVs charging or parked in older or near older buildings. Next slide. So the third working group deals with the whole issue of integration with the grid. This is probably the most complex to tackle. There are two pillars here, looking at communications and controls, and then power distribution and DVR integration. So we get into issues of architecture, again, looking at the different requirements regarding grid integration for different charging scenarios, how we measure EV energy consumption, issues around cybersecurity and data privacy and telematics, and then really breaking down the power distribution DER into the electrical power systems and safety, the communications control, cybersecurity, and then DC as a service or charging as a service. We're also looking at microgrids and distributed energy resource management systems. Next slide. So here, preliminarily, the gaps relate to locating and reserving public charging spots, including obtaining pricing information and near-time availability of a charging spot. On the measurement standards for EV submeters, their performance, security, privacy issues, who has access to the data, and then just sort of more generally metrology, coordination and control and reporting. And then on the power distribution DER integration, power quality requirements or expectations, and then we've got a number of other areas under discussion. Next slide. So our timeline, we actually began in June of last year. So the working groups have been meeting kind of twice a month for some time. Our goal right now, here we are in, I guess, the third week of January, is to have a draft available by the end of March. And that draft would, we're envisioning, go out for public review and comment for 30 days. So if you're interested in getting a copy of that and commenting on it, we would welcome that. And then we would reconvene the working groups during the May timeframe to dispose of those comments with the aspirational goal to wrap everything up by the end of June. So the last slide has my contact information. You can get more information at ansi.org/EBSP if you or email us at ebsp@ansi.org if you want to get on the distribution list. So with that, I will stop and turn it over to the next speaker.
Thank you so much, Mr. James McKay, for sharing about the ANSI Electric Vehicle Standards Panel, the roadmap of standards and codes for electric vehicles at scale. It is interesting to know that why we need a standard roadmap for EV. And one thing that I underline is on how we can maximize the coordinations among standard developing organizations. You also share about the roadmap overview, which focus on identifying issues and gaps and how to address the gap by using the prioritization matrix. So now I give the floor to Mr. Theodore Bond, the Principal Electrical Engineer at Argonne National Laboratory. Mr. Bond, you will have 15 minutes to deliver your presentations.
Okay, so Joe, can you pull up the slides? Thank you. So again, we talked a little bit about, again, I'm Ted Bond, Argonne National Lab, and this particular part is about an endeavor called EVs at scale. And so the Department of Energy is putting a lot of money into this area, have a lot of different labs working on the same problem in a different way with private industry and other stakeholders. Next slide. So in this EVs at scale, there are 6 labs. So Argonne Lab, Idaho National Lab, National Renewable Energy Lab, Oak Ridge National Lab, Pacific Northwest National Lab, and Sandia National Lab. And so Argonne National Lab is the first national lab of there are 20. And so we're part of the Manhattan Project with a 77-year-old history of the lab itself. So just to point out, Argonne is one of the first, and that's where I work. So we work with key stakeholders to on infrastructure research and look at the barriers. And again, this pillar for codes and standards is what funded the EVSP roadmap. So they're not just connected; they're the same project, but at a higher level. And so the research activities and innovations, so there's a lot of R&D going on for both on-road and off-road vehicles. I have some slides at the end for that. And then the technology to integrate charging. So the grid integration is a really big part of this, and cybersecurity to protect the drivers, the equipment, the personal information, and then of course the grid from different kinds of threats. Next. So the pillars, the first pillar is the vehicle to grid integration and smart charge management, or SEM, and that has the acronym of FUSE. I don't remember exactly what FUSE stands for, but that's basically VGI, vehicle grid integration. The megawatt level charging equipment, solid state transformers working at medium voltage input, and then different converter cells that are stacked and different energy storage. That's a project in itself to talk about how do we get more power into different locations, how do we site them, and how do we do the interconnection at the megawatt level. Dynamic wireless power transfer, which is basically wireless charging, but not just stationary in-road systems as well. That Oak Ridge is a carryover, so sorry about that, it's a typo. And then cybersecurity is stating the obvious, we need to secure our assets. And then the codes and standards is the pillar that we're going to talk about right now. So the codes and standards pillar has limited staff and resources. We had to pick what the top 10 are. And again, a bunch of that is captured in the EV standards roadmap. The last bullet on this slide is the top 2 of those 10. And again, the eye chart that we had on the previous one covers the 2953, 2954, 3072, all those different grid standards and other things. Those are important, but not as important or a big enough gap as the interconnection. How do we actually manage the power going to the stations? And then of course the megawatt charging, how do we actually get the electrons into the vehicle? That connector standard didn't exist. So that's the furthest behind on something that doesn't exist at all versus something that needs to be updated. Next slide. This is kind of an overview. So looking in the upper right is the point of interconnection. Whenever I say point of interconnection, we have the transmission and distribution to the substation. And so we'll have either 13.2 kV or 69 kV or whatever the voltage is on the distribution system going into some load center or whatever it is, and that's around where star number 1 is the utility interconnection. That point of interconnection is the biggest hurdle, right? And so in the United States, it can be up to 5 years to get your interconnection permit. Once you apply to have service connected, it could be years, not just months or weeks. Transformers are running, somewhere between a year of lead time when you order it to when you get it. So there's a lot of different things when you want to say, I'm ready to go, I'll just order the stuff, I'll be up next week. And it's like, you won't even get permits for a year. And some of these things won't have upgrades for 5 years. So that's a big part of it. The AC to DC power conversion is the fundamental part of offboard charging. How do you get the power into a form that the batteries can use? The DC distribution, and again, assuming you're using, there will be slides that kind of expand on this topic, is if I'm going to connect everything in parallel as a DC system, how do I do that? What are the distributed energy resource elements? And you can see on the upper right, the solar panels, the battery storage, the local generation. Bullet 4 is the dispensers and cables. We'll talk about that. And then the inlet and things that go on the vehicle. Next slide. So here's an example, and this isn't just a picture of an amoeba. This is actually a Google snapshot of a truck stop in California. So each one of these squares left and right on the side of the highway are 600 spots. So there's 1,200 trucks are parked, or spots for trucks in this photo. In the future, you might have 1,200 charging stations needed in just this one off ramp. And so it's a big challenge. It's both an opportunity and a challenge. Next slide. So this is at Argonne Lab. So in the upper left, you can see one of the research buildings. You can see the solar canopy with 80 kilowatt of PV. Kind of in the distance in the front, you'll see a clear picture of it is what looks like a fuel island. That used to be a fuel island. Now it's a charging island with a 500 kilowatt charging station and some 50 kilowatt charging stations. And then to the back of the building, you'll see some in the next slides, a close-up of the 0.5 megawatt and 1.5 megawatt charging stations. So you can see transformers, and again, it's a kind of a spaghetti mess for if you're not an engineer, but the different colored lines are different research busways that we have in the building, that we can isolate things. We can make the building into a microgrid. We can run off solar panels. We can run off storage. And so this is the breadboard that we use for conducting experiments to validate standards and to design new equipment, new controllers, and of course, the metrology, all the different things. This is one of the development centers we have called the Smart Charge Plaza. Next. So a little bit more up close, you can see in the lower left is what the stationary battery looks like when it was being installed. So the open slots on the left of the ISO container with the doors open are where the battery trays go. The center section with the vertical doors are the power converters, and then to the right is the climate control solutions, and that's inside that container. And that's a 1 megawatt stationary storage for peak shaving. It's AC coupled, not DC coupled in this case. You can see the 4 power converter cabinets behind the 2 dispensers in the upper left, and then behind that are the gray transformers and switchgear that are shown in the other photos. And so we have SCADA, which is the control and data acquisition. You can see different cars in different locations. Anyway, next slide. It just kind of grounds the point on what do we do and how do we divide this up. So on this slide, we just talk about the balancing act. And I always use an analogy of a pizza. So some people are very hungry, like a truck will be a football player and it will eat the whole pizza itself. It'll eat several pizzas. Other ones, like the delivery vans on the right, only need a certain amount of energy because they only run a certain number of miles per day, and they have a route and a time when they can come back and charge. So they don't need to charge fast. So the bullets in the middle say, if I've got 2.5 megawatt of interconnection, what can I do with that? And if I have a 2.5 megawatt charging system on an MCS system, then I'm going to take the whole transformer for just one vehicle. And again, to be honest, if it's 4.5 megawatt, I'm going to need 2 transformers to feed it, or medium voltage, if I'm being honest on how much power you're going to need. And it's going to be expensive, and it's going to be complicated, but you're going to get a lot done. You're going to get many miles of charging. So for the Tesla and other vehicles, they're aiming at 20 minutes to add on, 400 miles of range. So a lot of power in a short amount of time to keep the truck on the road as many hours of the day. So the middle ones just talk about, well, what if I can do 2 to 5 ports at 500 kilowatt each? That's where we're at today. Most of the semis and buses charge in the 500 to 600 kilowatt range for the big ones. And then most other ones charge at 100 kilowatt for a longer period of time. And then the delivery vehicles, so for instance, overnight charging, if I have an 800 kilowatt hour battery, for instance, then I can charge 8 hours at 100 kilowatt, and that seems very reasonable. And so I can have 10 to 25 100 kilowatt charging vehicles on that one transformer, running it up to the full rating. And then of course I can go up to 125 ports if I divide it down to 20 kilowatt, or delivery vehicles that run only 50 miles a day. They can be recharged, very slowly and very leisurely, and so you can schedule that. The last bullet talks about oversubscription. You really want to have more charging ports than you have vehicles, so you don't have to keep shuffling vehicles past the filling station. So it's like being hose limited versus fuel limited, right? I have a certain amount of fuel or fuel flow, but there'll be hoses that are not turned on, and it's nicer to have more spots with more hoses than I have vehicles, or put this way, I don't have to keep moving the vehicles up to the hose. I just have an extra hose. So that's what that indicates. And so, you could have up to 10 of those. So you could do 1,200 vehicles at 20 kilowatt on that transformer if you wanted to schedule it and stretch it out. But again, it's like that pizza. If everybody just gets a small piece, it's a small piece. If you get a big piece, it's a big piece, but it costs more money. So next slide. And again, that's the whole idea of scalability, expandability. So this is a view of what's called Electric Island. So that testing event with all the tents, this is what it looks like without all the tents and vehicles there. So you can see there are 4 pull-through lanes. There are 4 fueling islands. To the right, in the lower center next to the page number, you can see 2 transformers. Those transformers feed the switchgear, which are to the red rectangle in the lower right. And so that's the panels that feed the boxes that are in just above to the right of that. There's a yellow empty spot where there'll be secondary use peak energy storage. So that's the next phase of the part. And you can see there's an access control fence. And then that light tan line that runs diagonally across are cement covers that can be lifted up and reconfigured. So it's kind of like a living lab where they can move around charging stations and add and subtract equipment without digging up any ground. So everything's got removable covers on it. And so this is in Portland, Oregon, co-funded by Daimler Truck North America and Pacific Gas and Electric. So next. So this is an important slide on the EVs at scale. And again, it is a whole talk in itself, but I'll go quickly. The rectangle on the right, and so these are both from the IEEE P2030.13 on the point of interconnection. And so you can see the title on top. It's a guide. It's not a standard, it's a guide for electric transportation fast charging management functional specifications. How do I control it? How do I deploy it? So on the right is an AC coupled system, and you can see that MVLV is the medium voltage, low voltage bus. The red circle is a point of interconnection. That's where the utility ends and the facility starts. You can see in the lower center on the right side is the charge management system. That's mostly where this vehicle grid integration and other smarts go on. All the different dotted lines are the nodes that this management system can see and or communicate with. So directly to the right of the charge management system are the AC to DC charge stations that we showed pictures of earlier. And then the EVs are the end load. Straight up the middle is an AC bus, much like any distribution system today with the load centers we showed in the previous images that have AC to DC conversion with storage, photovoltaic, other HVAC loads that are tied into that AC distribution bus. And then just to the lower left of that figure on the right, what's called DERMS, so the Distributed Energy Resource Management System. And then the service provider, which as we talked about, those are the people who actually provide the energy services, provide the billing and all the different things. They have controls of that. So the bigger magnified one on the left is what's new. And so this DC as a service. So in the United States, the utilities are allowed to collect a fixed amount of rate-based return on investment. And so every investment they make, they're allowed to collect a certain amount of profit. The DC equipment they would like to own. So in the past, you would buy AC power and you would convert it yourself. In this case, the utilities will convert the power to DC, and the end user on the lower right where you can see the 2 dotted lines, it means a DC fed charging equipment. And that would simplify things for the site owners. And then of course the controls get more complicated and the tariffs get really complicated. So 2030.13 addresses this. There's something called the Energy Services Interface. Like I said, I could talk a whole hour on that, but those energy services have a huge value. In fact, they have more value than the bulk energy. So you usually have your energy bill and your demand bill. And that demand bill will often be greater than your energy bill. So that's just the way tariffs are designed. This is a standard that covers that under the EVs at scale. Next. And so I showed the example of the on the cover of the J3271 megawatt charging system. So this one is end to end. It covers from the point of interconnection to the battery terminal. So it's not a connector standard, it's a system standard, and it includes the sections we'll talk about in a second. So the version 0 was released last year as the first draft. And again, the more drafts we can get out, the more people can review it versus other standards organizations wait until it's done. Then you have to wait 5 years to see the first version. We've been working on it for 1 year and 4 years previous to that under the Charan work groups. But the point is that this thing is for anything that rolls, flies, or floats. So it's for trucks, bulldozers, airplanes, boats, truck, just any large object and large battery object. So because we don't want this to be a 1,000-page document, it's broken into 5 subsections. The first subsection is purely electromechanical. All the drawings, testing requirements, drive over requirements, impact drop requirements, just anything that has to do with electromechanical requirements to get to that 3,000 amps. We're going to have 200 amp rated connectors, 350 amp rated connectors, 1,000 amp rated connectors, and 3,000 amp rated connectors that have different cooling systems. That document describes how you test them, what the reference devices look like, and all the procedures harmonized with you'll see on the next slide, the IEC 63379 and other standards are harmonized to that section of this document. So as other systems might have multiple documents, this has one document with different sections. So it's kind of like having an encyclopedia, but you have one volume per topic, so you don't have to lift a 50-page book or a 50-pound book. Second part is the physical layer on the software communication. So anything that has to do with communication controls is in that one, and all the protocols and security and other things. Charging cables, cooling, cord handling, automated connection systems. It's going to be a big issue with 3,000 amp cables. They're going to be heavy. They're going to be unwieldy. They're going to get damaged. They're going to have multiple connectors on vehicles. So you're going to have boats that have 3 inlets. At 3 of those are going to be a 9,000 amps. And so handling that is going to be an important section on its own. Use cases, that's going to probably be the biggest part of this standard, and it covers the DR, microgrid, auxiliary power, all the stuff in P2030.13 that we just showed is going to be in there. So again, it's a very comprehensive document. The last part is how do we test this? So interoperability and testing requirements. There's a dual to this one called AAR 7357. I'm the chair of that standard as well. That one's specifically for aircraft. So anything that doesn't have to do with anything with wheels, you just leave all those sections out, and it's just aircraft. Next slide. So some people say, I see circles and dots, what do they do? Well, obviously the biggest pins on the top are the power pins. They're 20 millimeter diameter. And again, they're able to carry 3,000 amps continuous. You can see the little guards in the middle are fingerproof, so you can't stick your finger there and touch any hot surface, and they're interlocked, so it would never be live. The 2 tiny pins in the center says the provision for 2-line communication. Those are 8 millimeter spacing, allowing us to use Ethernet. So the 3 physical layer communication that we're asserting are CAN, Ethernet, and power line communication. So in the SAE world, it'll be a multilingual system, and that different industries can do that. You can see the yellow arrow that says lock options. So there are slots in the housing where the big locking bars, and you can see on the far right, there's a little box that's a servo motor that pushes a pin and locks the 2 sections together, such that when the connector is mated, it can't be unmated until it's unpowered and cool. In the lower center, you can see what's called PE, or protective earth, and that's like your tools and appliances. If there's a short in the battery, all the fault current goes down there, and we test to 100,000 amp short circuit peak, or 3 mega amp second squared, if anybody understands what that number means. And then it says the pilot signals there's some communication interlock and auxiliary power. So you can see on level 1, and again, we're changing the terms. It's not going to be level, it'll be configuration 1, configuration 2, and configuration 3. Configuration 1 has no cooling. It's just passively cooled, and we believe you can get 350 amps out of a system that doesn't have any external cooling. Level 2, you're going to have to cool the cable and the connector. Level 3, you're going to have to cool the inlet and the cable at much higher rates. So next. They'll all be electromechanically compatible, but they'll have different ratings on how much performance. This is kind of a timeline. You can see the 4 standards on the top: the ISO 5474, 63379, 62851-23-3, and 5118-20-6-10. Those are each separate standards, and they're harmonized with the SAE standards and vice versa. So we just talked about 3271 and 7357. And you can kind of see the timelines for the ISO IC standards are much further out to the right. The SAE standards, we can move faster because we have stakeholder meetings that you're there in your own qualifications, and that's what we were talking about earlier, and that we can move faster because we have more meetings without a lot of overhead. So next. So these are the tail slides are just examples. How does this work? So you can see on the left, you can see all these little bricks, these black things that look like giant chemistry books. Those are the power converter modules. In this case, on the Terra 360 has a whole bunch of modules in a rack, and this one has up to 4 dispensers that can cover four vehicles, or you can have all of it to one vehicle. In the middle, you can kind of see the timeline 2019, 21, 22. In fact, this now outdated slide. We have the 500 amp stations, the 1000 amp stations in a small container, and the 3000 amp stations in a bigger container. So this is basically how things you can buy today. Next. Here's an example of CAT doing things with big trucks. So the 793 mining truck is running in Arizona autonomously. So it runs 1000 hertz and it's been running mining up and down. And this is how they charge that. In the future, they'll be using MCS. Next. These are some screenshots from the Consumer Electronics Show, just showing more products that have the MCS connector already on it with the what's called the MB460 power converter cabinet. So next. This is a different view of the big cabinet on the right. It has all the modules of power electronics, the cooling, the maintenance things we talked about, the installation, the slab, the slinging to put it in place. It's all kind of that way. And then the dispenser that's out in front, the big black box with the cord and the fans and the meters. Next. This is just a different view of what's on the display, the information. There you can see a representation that has CCS and MCS connectors coming out of the dispenser. Next. And last but not least, just an example of aircraft dispensing systems. So a company called Beta has this vertical takeoff aircraft in the upper right. And you can see there are 2 boxes. One is for cooling systems and one is for charging. It has a door that slides up and down and a big cable reel that allows to pay out the cable, charge the aircraft, and then they push the button and pulls the cable back and close it up to keep it off the ground and keep it clean. You can see the vertiport on the left. So those are just examples of things that are using the megawatt charging system today. That's it.
Thank you very much, Mr. Bond, Principal Electrical Engineer at Argonne National Laboratory, for highlighting the critical standards for EVs at scale and priorities under the codes and standards pillar of the US DOE. You also stressing the codes and standard pillar has limited staff resources and funding, leading to the need to prioritize the top 10 gaps of the standards needed for EVs at scale deployment. And thank you so much for highlighting the top 2 gaps that you already mentioned. Well, I now give the floor to Mr. Bram Hertasning, Deputy Director for Urban Transport Policy at Transport Policy Agency, Ministry of Transport, Indonesia. Mr. Hertasning, you will have around 15 minutes to deliver your presentations, and now the floor is yours.
Thank you, Stiara. Assalamualaikum warahmatullahi wabarakatuh. Everyone can hear my voice? Okay, good morning and good evening, everybody. First of all, let me introduce my name first. Can you show my presentation, please? Anyone? Okay. My name is Bram Hertasning, and now I'm as a Deputy Director for Urban Transport for Policy Center for Traffic, Road, and Urban Transportation. It is one of the body under the Ministry of Transportation. And this morning, I will bring some presentation about national EV policy and regulation. We already heard a lot of interesting presentation from the previous presenter. Next slide. This is my outline. I will divide my presentation in 4 main area. First is legal basis, current situation, ministry response, and recommendation. The previous presenter already present a few interesting topics. I take note like Joe Bablo talk about standardization, and also Jim McCabe talk about technological gap. Those 2 topics I will discuss in my presentation too. Next, our legal basis. As we know, the commitment of the President Jokowi in fighting global warming by limiting the use of fossil energy and replacing it with other alternatives is starting to be realized. One of which is the issue of the Government Act number 55 year 2019 and strengthened by Presidential Instruction Act number 7 year 2022. Next. National roadmap concerning EV. Furthermore, as a cascade of the regulation previously passed, Ministry of Industry has made a roadmap regarding EV implementation in Indonesia. Last year, we have started a major shift and socialization of EV to the market. Ministry of Industry has also said that in 2025, they targeted 20% of all vehicles in Indonesia will be categorized as green car. As per November 2022, we have around 7.5K electronic car, 58 electronic buses, and 25K electronic motorcycles. These numbers are still far from the targeted number in 2025, only 2 years to catch up. So the target in 2025, which is 20%, is we have to work hard to achieve the target. Next. Partners commitment. In Jakarta, we have a public transport we call Transjakarta. And this you can say that Transjakarta EV bus roadmap. Transjakarta already have program for their EV fleet proportion from 2020 until 2030. We also need to appreciate the effort of our partners to support electrification public transport, which is in line with the national roadmap. For example, Transjakarta targeted 10,000 buses in 2030, which is 83% of them use the electrical vehicle. So in the year of 2030, Transjakarta targeted that 83% of their fleet is already EV. Next. This is existing EV in Indonesia. Here are some examples of the bus already operated in Indonesia. Next. Beside bus, we also have Tesla as a premium taxi in Indonesia. Next. I think you... Back. Can you back one slide, please? Yes, this is the current situation in Indonesia. And I think it's not only happened in Indonesia, but also happened in most of the Southeast Asia. You can see that there are high congestion, tropical climate, and floods. In most countries in Southeast Asia, in certain period of the year, we even have our private pool. As you can see down there, we have our private pool there. We also want to point out some of the issues regarding EV implementation in Indonesia. First, high environment temperature, which is not ideal for EV battery operation. 2, frequent flood in cities, also not ideal for electric motor and battery. 3, high congestion might also be incorporated with too high operational temperature. And last but not least, various charger types from different region manufacturers will most likely create inconvenience among users. The 2 previous presenter in this section, which is Jim McCabe and Theodore Bond, already mentioned that, as you can see on the right side, that ununiformly chargers. So different EV supplier, they come to their market with different chargers. That can be cause trouble too. Next. This is the current situation regarding safety concern. There are some issues regarding safety concern. One of them is fire from EV are hard to put out, which might be caused from several events. They can be caused with vehicle crash, system overheating, and system malfunction. We put special attention regarding EV safety, as it is the ministry duty to ensure transportation safety. One of our concern area cases are fire, which might caused by crash, overheating, or other malfunction. They were harder to put out. We understand that countermeasures and mitigation that we have need to be adjusted with the new technology. And we hope through this workshop and further communication with all related parties that we could create a safer EV vehicle for all. Next. This is some ministry response update regulation. For example, this is our technical periodic and roadworthiness testing for electric vehicle. This is, I quote from Transportation Minister Regulation number 19, year 2021, concerning vehicle. In response of the safety concern, we at the ministry has updated some of our regulation regarding vehicle testing, so that our team on the field could cooperate coordinatingly and ensure the roadworthiness of EV. But even so, there were still many aspects regarding EV operation that we have not yet covered, such as flood testing and emergency mitigation. Next. This is some our ministry response. As a transport policy board, we already issue some policy regarding this EV. As you can see there, some issue regarding the EV. Having seen the development of EV technology and its growing use in Indonesia, as well as the potential obstacle in implementing it, the Ministry of Transportation have instructed us as the transport policy agency to analyze and formulate national policy on EV. The agency has formulated 9 points of national policy regarding EV. And we felt there are 4 points that match with today's agenda. As you can see, I already stated 4 points, which is building a sustainable ecosystem, fulfilling availability of charging station, ensuring safety procedure, and establishing risk mitigation policy upon accident involving EV. Next. We also have some international engagements. As you can see there, we have some correspondence with International Council on Clean Transportation, or ICCT, because as to help ICCT to review about their upcoming policy paper about accelerating the use of EV buses in Indonesia. We have already sent our replies, and we hope for constructive dialogue in the future. Next. This is our recommendation that the need of sustainable corporation. We already conduct some research. We have consulted with some academics, experts, and business representatives about how to the best implementation of EV that suit the condition of Indonesia. And we all agree that a form of ecosystem that would cover all EV activity as a whole is needed. We may categorize the ecosystem into 4 main elements that will need to top priority. 1, the electric vehicle itself. 2, the charging infrastructure. 3, battery technology. And last but not least, to maintain the environment, we need to think about the battery recycling too. Next. This is the intergovernment policy integration. As you can see, there are different government ministry that involved here. To realize a sustainable EV ecosystem in Indonesia, Ministry of Transportation does not work alone. In fact, our ministry are actually at the downstream parts of this whole cooperation. It is important that all related ministry and institutions to be involved to create a meaningful communication and gain expected result. As you can see, there's a Ministry of Industry, and then there's even the Education Ministry and the Natural Resources Ministry. Next. Our recommendation, we already sum up a few things. I may mention 3 main, which is build a broadly reliable electric vehicle ecosystem, which include infrastructure, industry, investment, financing, marketing, and regulation, which need to be fulfilled synergetically and collaboratively with careful planning and high commitment from all related stakeholders. Prepare facilities, infrastructure, procedure, mitigation, and human resources to ensure the fulfillment of service capacity and test standards, which ultimately create a safer operation of EV in Indonesia. And last, EV that will be operated in Indonesia should adhere to standards that incorporated both natural and actual condition in Indonesia so that the user could be benefit with the advanced technology of EV. The most important slide, next. Thank you.
Thank you.
Thank
very
you.
much.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Mr. Hartasning, for sharing the national EV policies and regulation in Indonesia. It is great to know that MOT is currently formulating the national policy on EV, and there's some of recommendations regarding the EV standards. You also share about some challenges that I think most of ASEAN countries also experience this. And it is great to put special concern on safety as the standard for the EV standardizations. And last but not least, interesting to see that collaborations among the MOTs and other stakeholders to make sure the policy regarding the EV is integrated. Well, now I will open the floor for the discussion session for around maybe 10 or 15 minutes because we are a bit running out of time. So there's some questions in the chat box. And thank you so much, Mr. Makeup and Mr. Bond already answered some of the questions. And one of the question is left is for Mr. Bram. Is the logistics sector considered in the national plan for EV? Mr. Bram, you may take the floor.
Yes, as we all know that logistics sector is one of the main important part of the transportation, and we already very clear about logistic plan in EV. But as we can see that it takes times into fulfill it EV in the logistic area. But yes, to answer that question, yes, we already put logistic in the plan for development of in Indonesia. Thank you.
Thank you so much, Mr. Hartasning, for questions. So I will have questions, maybe this question for every speakers for these sessions on how can standards help address these challenges that you already mentioned about some challenges when we creating the standards, and we would like to know more about how these standards can help to address those challenges. Maybe I will give the floor to Mr. Makeup to answer the first.
Well, I think the points that were made earlier by some of the speakers about international harmonization, obviously having standards will reduce the possibility of costs being passed on to consumers. If you've got a multinational who is a vehicle manufacturer, for example, or a charging station manufacturer like a Siemens, someone like that, having, ideally, one international standard helps. We don't always get there. There are some competing standards in the market, but that is always the goal.
Okay, thank you so much, Mr. Makeup. So, Mr. Bond, do you have any thoughts on this?
That was for me.
Yes, how can standards help address these challenges?
Yeah. So as Jim was saying, there's a lot of people who want to make barriers, increase the barriers, and there's some people who want to decrease the barriers. And so the working together, when people see the big picture, we can harmonize and we don't have to compete. Other ones, they intentionally make things not compatible. And so standards can be used as a weapon as well as a bridge. So that's the way it's gone. There are people who intentionally, especially for patent protection and other reasons, want to increase the barriers to entry. Others want to reduce.
Thank you so much. Mr. Hartasning, do you have any thoughts on this?
Thank you, Estiara. Interesting question and also interesting answer from Mr. Jim Makeup and Theodore Bond. In my opinion, as a regulator, how can standard help address these challenges? Well, it will indeed help in many aspects. Mainly, if I can mention three: safety, testing procedure, and convenience. For safety, by acknowledge various EV operational area, especially in tropical countries such as Indonesia, we can ensure that EV are safe to be used everywhere in the world. And about testing procedure, our team on the field experienced difficulties upon testing new EV. They said that EV manual came from multiple manufacturers that might not share common system nor parts. Even worse so, some manufacturers didn't even include proper manual for us to execute testing. This is maybe for other speaker, another new perspective that we in tropical countries and Southeast Asian, Indonesia especially, we have some difficulty that some of the EV that come is from different standard and different charging, and some of them don't even give manual, and it gives us any trouble too in the field. But last, about the convenience, with current condition, which is regional automotive manufacturers supply their own charger, it is very difficult to provide various charger station at one location. This might also cause issue of space inconvenience. So as I mentioned earlier, with different type of chargers, it's difficult to us to supply different charging station in the area. Maybe we could consider that in our further discussion. Thank you.
Thank you, Mr. Bram. So there is some question, and I think it should be to Indonesian also for Mr. Bram. So I'll read the questions. For Mr. Bram, how many charging stations are already installed throughout the country? What is your view on the rollout across cities in the country? And is there example of an effort or initiative carried out in Jakarta to protect EV-related infrastructure or asset from climate factors? And to foster EV ecosystem, from what I heard that Indonesia planned to give subsidy for purchasing EV from 2023. When can I confirm specific scheme for this? And hybrid vehicle can be included this subsidy program. From my perspective, focusing on BEV solely is very important at the early stage of EV ecosystem. Maybe you can wrap up all the answer in the 1 second.
Okay, thank you, Estiara. May I know who answered that question, Estiara?
Anonymous attendee.
Okay. Maybe for just a suggestion for all the attendee, maybe if you give a question, please state your name and the institution you came from. I will try to answer how many charging station. Well, now in Indonesia, because all we know that Indonesia is a big and archipelago country, a lot of island in Indonesia. Honestly, right now we are already only install the EV charging station in the big cities, but that doesn't mean that we doesn't put any concern in the other. We already put the planning to install. And then, for example, in Jakarta, we already install charging station in some public areas, like it's in station, and then in the highway, in most of the rest area in highway in Java is already have charging station. And then talking about the subsidize, well, we the government already have planned to give subsidize, not just to EV but also hybrid. That to answer this question, I think it's not in my capacity to answer the question, because the real scheme of the subsidize is still already discussed with other industry. So putting subsidize, I cannot give further information, but we will give subsidize, and we still discussing the proper scheme, because we don't want the subsidize give to the wrong area. And what's the next, Estiara? You said how many unsubsidized?
Oh, I lost the questions.
Okay, I think that's can wrap up the question. And for the next attendee who will ask question, please state your name and your institution came from. Thank you.
Thank you so much. Well, maybe the last questions for Mr. Makeup and Mr. Bond. Given diverse regulatory systems and electrical safety infrastructure elements in different parts of the world, how likely is it that we will achieve internationally harmonized EV standards? Please, Mr. Makeup and Mr. Bond.
Well, I think there is probably always going to be some differentiation, just as we have different electrical plugs for home appliances. There will probably always be some differences. I think the efforts, these kinds of information exchanges that we're doing here today, and obviously working international standards organizations, whether they're Geneva-based or US-based or otherwise, can help bring about harmonization, which again is really to the benefit of the end user consumer.
Thank you. Mr. Bond, your perspective on this?
Yeah, and again, it all has to do with attitude and also the liaison part of it. Are we actually talking to each other? Are we talking at each other? And so Jim has been with me in many international meetings. Sometimes from day one, you're talking at each other or over each other. And then other times, right off the bat, you can figure out what you have in common. As I always say, you have more in common than you have differences. And working out those differences don't always have to be economic. And so the greater good. And then it's also with technical innovation, sometimes things that were impossible to do 5 years ago are now very possible. And so as we were saying on the previous panel, standards evolve. And so, but the harmonization takes, much like any political and diplomatic endeavor, it takes good faith and goodwill. Some people aren't listening, others are. And so I think that's really what it takes, is an open mind and an open ear.
Okay. Thank you so much, Mr. Bond. Maybe any thoughts on this, Mr. Hartasning?
Yes, Estiara, may I edit the answer for the previous question? How many charging stations there in Indonesia? As per November 2022, there are already 1,444 charging stations in Indonesia, divided in the two categories. First, the one which only normal charging is 483, and the next is the one that you can do battery swap. I mean, is you charge your car and then you can leave your battery there, and then you can get extra battery that you can use. Is 961. So total by November is about 1,444 charging station in Indonesia. Thank you.
Thank you so much, Mr. Hartasnings. Well, distinguished delegates, finally, we have come to the end of this session. So to conclude these sessions, I believe we agreed that EV standardization is a crucial element to accelerate the EV's implementation. The benefits of international standards and conformance to support the development of cutting-edge and sustainable EV supply chain and ecosystem in the ASEAN countries, while promoting international trade and technical exchanges between US and its ASEAN partners. It is a pleasure for me to moderate this session. I would like to thank and appreciate all distinguished speakers, delegates for the contribution and active participations. I would like to appreciate and thank the USTDA, USDOT, ASEAN Secretariat, NC, and also the Ministry of Transport for conducting such a great workshop. Well, thank you so much. And back over to you, Alison.
Thank you, Estiara, and thank you to all of our amazing speakers and to everyone that submitted questions into our Q&A. Before we move forward, I'd like to ask everyone for a group photo. Again, give me your best smile.
Saya kirim dari yang Bapak. Saya nggak dukung Bapak.
On 3, 2, 1. Thank you. As a reminder, if you have submitted a question and we didn't have time to respond to it, we will provide all these questions and in the following workshop materials after the event is over. Finally, we will move towards the wrap-up remarks, and I will present to you Mr. Kevin Tugers, Country Manager in the Pacific U.S. Trade and Development Agency. Kevin, the floor is yours.
Thanks so much, Allison. And I want to thank everyone for your participation today, and particularly our speakers for their presentations and really for sharing their thoughts and perspectives on some of these key issues. We appreciate your taking time to engage in this important discussion on development and adoption of EV standards in ASEAN and also globally. Today's session, we focused on standards for EV charging infrastructure and standards cooperation and development. In the first panel, you heard about the role of standards in ensuring EV charging infrastructure that is interoperable, that is connected, that is safe, that is also secure. And in our second session, our panelists discussed national EV policy and standards development and cooperation, including using the ANSI EV standards roadmap and Indonesia context as 2 examples. Tomorrow, we will reconvene to discuss 2 other key topics: vehicle safety standards and standards for the life cycle of EV batteries. We will hear from the US government's National Highway Traffic Safety Administration, NHTSA, and the US Department of Commerce, as well as the American Automotive Policy Council and the Malaysia Automotive Robotics and IoT Institute. In the second session tomorrow, we will hear about the full life cycle of EV batteries from UL, the Electric Vehicle Association of the Philippines, and also the Economic Research Institute for ASEAN and East Asia. We hope you found today's discussion to be a strong starting point for our engagement and cooperation on this topic. Shortly, you will be receiving more information from ANSI about the workshop survey that can be completed today or tomorrow if you plan to join both workshop sessions, days of our event. I would like to emphasize that this survey is really critical to USTDA's ability to support workshop like the one today and to justify new potential opportunities for collaboration. So we very much appreciate your feedback. With that, I would like to thank you again for your participation today, and we look forward to seeing you again tomorrow for the second day of our EV workshop on technical standards. So with that, Allison, I will turn it back to you to formally close our session.
Thank you, Kevin. And with that, the first session of the day 1 comes to an end. Here's the link for us to complete the Q&A section that, excuse me, the Q&A link to fill out all the questionnaires. Well, thank you for joining us today.